Do you remember the last topic? It was convection radius. Right? That was the last one. Okay, guys, I'm just going to mute everyone. We're going to start our session. Okay. Okay. Okay, slide change. 4 years back, okay, the blueprint we were focusing like we had like safety and built environment for 2%. Now it has increased to 5%. Now what they have done is that they have collaborated section 19 structural fire elements. Okay, they have collaborated with safety and built environment, and they have made it 5% of the examination. Water-based suppression system was 17%. Okay, now it's 20% of the examination. Okay, and now they have increased the percentages of facility fire hazard management up to 15%. Before it was 11%. So now there are slight changes. They have added new chapters. Okay, and that is why we are going to have a slight diversion. Majorly 70 to 80% of the syllabus is same. 20% addition is there. Okay, and you have to make sure that this time you clear it before the year end, because now they are going to change the book. By the end of this year, they will be changing the book to 21st edition. Okay, yeah, the new one. And that book is very expensive. It's $750. So now this book is still $290, $300. That is twice the price. $750 or $790, something like this. Okay, so it's much more expensive. So better pass it this time. Okay. Okay, so in the last lecture, we had discussed about and the CFPS, we were discussing three very important fundamentals: heat release rate, flame spread index, and smoke development ratio, right? Today, we are going to move on. We have discussed about the heat transfer mechanism also, right? Conduction, convection, and radiation, okay? So today, we are going to move on towards the next topic, that is the flame structures, okay? See if it's visible for the online students. Okay. Yeah. Flame structures. Flame structures can be categorized into two types. Okay. The first type of a flame is a pre-mixed flame. The second type of a flame structure is known as diffusion flame. Okay. So we have been mentioning this in the CFPS examination also, that in the examination, all the questions are not going to be that much tough. Okay. That's better. All the examination, all the questions that we're going to discuss, okay, they are not going to be difficult questions. Okay, they're going to be easy questions, and most of the easy questions will be directly from the definitions itself also. Okay, so we don't want to depend on the book too much. Okay, we want to solve easy questions quickly. Okay, and that is the secret why people, they tend to pass the exam very easily. Okay, so pre-mixed flame, from the name itself, pre-mixed means there's a mixture before the reaction. Okay, so pre-mixed flames are those flames in which air and fuel are mixed before ignition. Okay, in which air and fuel, they are mixed before ignition in a controlled manner. Our combustion engines. Okay, so what happens? Air and fuel, they are mixed, and then an ignition source is available to control the amount of heat. Okay, so if I want to actually control the premix flame, or if I want to extinguish it, or I have to just make sure that there is no specific propagation, uncontrolled manner, okay, I can only disconnect one thing. Either I can stop the air, or fuel, I can stop the premix flame. Very easy for me. That is why in the combustion engines, or in any type of controlled laboratory experiments, wherever we have premix flames, okay, we can easily control them. The problem comes with the diffusion flames. In the diffusion flames, what happens that air and fuel is gathered after ignition. Okay, they burn in the region in which they mix. Like for example, what happens in a diffusion flame? Let's say any type of an incidental flame has appeared. Now fuel is available here. Air is unlimited, right? So I cannot remove air. Even removing of air from the environment is not possible for me. So the only way I can control the diffusion flame is by interacting with the fuel. So that is what we do in our in our active devices. We interact with the fuel itself. Our extinguishers, they interact with the fuel, right? Sprinklers, they interact with the fuel, right? And above the fuel, we can remove the oxygen, right? That is the process that we tend to use it for our diffusion flames, to control the diffusion flames. So flame structures are of two types. They can define any type of a definition. They can define any of these flames, and they can ask you. In some of the questions, they can simply give you a scenario also. Now the CFP, they have diverted the questions a little bit more trickier. Okay, they can simply ask you a question providing an assembly occupancy. Okay, an assembly occupancy undergoes an ignition stage. Okay, interaction with a fuel diverts to which type of a flame. So they can give you premix flame, diffusion flame, or anywhere. Now what happens is that now our concentration is like, okay, they have mentioned assembly occupancy, so there must be some
Hello,
trick there, right?
excuse me. Excuse me. Hello, excuse me, sir.
Hello. Yes,
Yeah,
hello.
this is Girish.
Yes.
Sir, which chapter we are covering today?
Section 2, same. The last one that we have
Say,
covered. Yes. Section 2, basics of fire and science. We covered up to conduction, convection, and radiation in the first lecture, right?
yes, sir. Okay.
Yeah. So okay,
Thank you.
it's a continuation from there. Okay. Section 2, basics of fire and science. So now the question that comes in the examination, it more focuses. Now our focus will be on the business occupancy, right? It's an assembly occupancy, but why the question has mentioned the type of an occupancy, okay, that becomes our concern now. Okay, now, and we tend to divert ourselves from the main point of the question, what it's focusing on, right? And our all focus is on the type of the occupancy. This is something that happens. Usually, they try to trick you around in these questions. Okay, so just keep your nerves, okay, and we have to make sure that what they are asking, we have to pinpoint it to it. Okay, CFPS is not about the codes. Remember that. Okay. But whatever the occupancy they are talking about, keep that occupancy in mind. But for me, your main focus should be on the question itself, what they are preferring towards, what they are directing it towards. Okay. Like for example, most common question that usually comes in the CFPS examination is that in an assembly occupancy, the minimum egress of illumination of egress should be okay. Now NFPA1 says that the minimum egress of illumination should be 1 foot candle. Okay, that is 10.77 lux luminations. Okay, so that should be that. Now that is something that is the minimum. Okay, so now when this question comes with an assembly occupancy, so most of the students, they think, okay, now maybe in the assembly occupancy, there must be a different type of a criteria, there must be some different readings for the illumination. So they tend to go throughout the book, throughout the whole chapters, and they will not find it answer. In the end, they are wasting their time. Okay, so eventually NFP1 is very clear about egress lighting. Okay, egress lighting should be 1 foot candle minimum, means that when the batteries of the emergency lighting is completely about to discharge, it should give you an illumination of 1 foot candle. Okay, that's the minimum one that should be available, right? So don't focus on the just keep your focus on the question what they are asking. So eventually you will see that they are defining you the easiest terms there. Okay, the questions will become more easy. Okay, so sometimes the questions are very easy, okay, but they tend to add additional information just to trick you around. Okay, so in just keep at the back of your mind, in the CFPS there is no specific codes. Okay, they are not going to ask you more specifically in detail about the codes. Okay, it's an explanation of the codes. Okay, so flame structures, we have two types of flame structures that we have discussed, premix flame and diffusion flame. Moving on, let's discuss about the chemistry of fire. The chemistry of fire, starting from atoms. A basic structure of atoms. We usually have a proton and neutron. A proton is a positive charge, neutron with neon charge, neutral, and they are usually revolved by the negative charge electrons, right? So this is the basic structure of an atom. Atoms are also known as they're also considered to be the building blocks of chemistry. Usually this question comes, which are the building blocks of chemistry? Okay, they will give you molecules, elements, substances, atoms. So atoms are the building blocks of chemistry. Okay, so moving on, what is the atomic number? If you remember, okay, we have discussed the atomic number in the last lecture also, where we were calculating the gas molecular weight, right? We were discussing about the molecular weight of the gas, and we discussed it, what will be whether it's higher or heavier or lighter than air, right? So based on that, we were discussing about a molecular weight, and there we had discussed the atomic weight also. Anyways, the number of protons in the nucleus of an atom, okay? Number of protons in the nucleus of an atom is the atomic weight. Okay, atomic weight can never be calculated without Avogadro's number. Okay, and what is the Avogadro's number? (6.022 into 10 raised to power 23). Why do we use Avogadro's number? We use Avogadro's number so that we can get a reasonable value. When we are saying that carbon, okay, has a weight of 12, mass of 12, okay, does carbon really have a mass of 12? No. The weight of carbon is far more less. But I cannot use that value for reasonable calculations. So I use Avogadro's number. I multiply that value with Avogadro's number, and I get a reasonable value like 12, oxygen 16, nitrogen 14. Okay, so like this, I get a very reasonable value. I can do the calculations, and when I want to convert it back into the gram, I will just simply divide it, and I will get the answer directly in the Avogadro's status. So that is why we usually calculate the atomic number whenever there's an atomic number or molecular weight. Okay, Avogadro's number is there because I need to know what is the weight of the atom. That weight of mass of that atom provides me information that how I can use it for further calculations. It makes it easy for me. Then we have isotopes. Isotopes in which we have same number of protons but different number of neutrons. Okay, so these are the isotopes. Any substance that is composed of only one atom, okay, that is element. Composed of only one atom, like carbon, nitrogen. Okay, they are elements. Molecules. What are your molecules? Molecules, atoms in fixed proportions. They are your molecules. For example, when we are saying 2 atoms of hydrogen plus 1 atom of oxygen gives me 1 molecule of water, right? So basically, atoms in fixed proportion gives me a molecule. So 2 atoms of hydrogen, 1 atom of oxygen gives me 1 molecule of water, right? So that is H2O. On the left side, okay, I usually have reactants. They are known as the reactants. And on the right side, I have the products. Yeah. In the examination, any definition can be there. Sometimes they simply they may simply give you the Avogadro's number. Okay, give you 4 options: 6.022 into 10 to the power 25, 24, 21, 23, something like this. All are near to each other. So if you know these values, you don't have to go to basics of fire and science. You don't have to go to the chemistry of fire. And then in the atomic weight, you will find Avogadro's number. but you don't have to go throughout all search if you can know this value, right? So it will be easy for you to simply highlight the value. Yeah. Whenever we are talking about the chemical reactions, okay, in fire chemistry, one of the reaction is very important. That reaction is usually made by the stoichiometric mixtures. Okay, we'll see what the stoichiometric mixtures do. Stoichiometric mixtures, a base of something that we want to, you can say, in other words, collaborate, something that is very difficult for us to extinguish. Whenever we have discussed up till now in the basics of fire and science, combining the first lecture and today's discussion, we have discussed that the water and carbon dioxide has been always one of the most effective agents. But water and carbon dioxide cannot be applied on all types of fires, right? And like, for example, if I have any type of metal oxides, water and carbon dioxide is ineffective. Oxidizers, your nitrates, nitrites, chlorides, persulfates, chlorates, bromates, this all water is ineffective. And similarly, carbon dioxide is also ineffective. Why? Because they are oxidizers. Okay. But stoichiometric mixtures is different from there. Stoichiometric mixture says that before a chemical reaction, fuel and oxygen is available. So let's say if I have any type of a fuel plus oxygen available with me, okay, when a stoichiometric mixture is applied, what it tends to do, it consumes the all fuel and there is no oxygen left, meaning it converts fuel and oxygen into products, okay, that are no longer flammable. They may act as an extinguishing agent. Okay, so okay. So you can see here, once a stoichiometric mixture is applied, okay, before the chemical reaction, I had fuel and oxygen with me, right? But once the chemical reaction has completed after application of the mixtures, okay, we have both extinguishers. Okay, so usually we use it as a base to understand that various types of fires, okay, where we have certain limitations, okay, we want a chemical break chain reaction. Okay, this chemical break chain reaction breaks the molecules and converts them into products that helps in extinguishing the fires. Okay, so that is why the stoichiometric mixture plays a very important role. Okay, so stoichiometric mixtures are actually a type of a base in which we tend to understand that various fires like reactive metals, sodium, titanium, potassium, okay, magnesium. Now there I cannot apply water. I cannot apply carbon dioxide also. Reactive metals where the temperature is above 1800 degrees Celsius. Normal temperature for a metal fire is 1800 degrees Celsius. Okay, I cannot apply water there. Why? Because at that temperature, what will happen? At 1800 degrees Celsius, that temperature is very high. And what I'm trying to do, I'm trying to apply water on it. What is water composed of? 2 atoms of hydrogen and 1 atom of oxygen. It will break the molecules. Hydrogen will exothermically increase the chemical reaction. It will propagate the flame. Oxygen will act as a further oxidizer. So that is why when you apply water on metal fires, okay, what happens? Reactive metals, the molecules break down. Now, hydrogen as a lone agent, okay, as a lone agent, it is always going to exothermically increase the reaction. Okay, the heat, the temperature of the fire is going to rise, and oxygen, it's going to be an oxidizer. So water is a very wrong agent for metal fires. So what I want a type of a system in which I can actually cool down the metal, first of all. Secondly, absorb that material should have the capability to absorb that much amount of heat without breaking its molecules. Okay, so that is why whenever we have a different types of extinguishment, we usually say we have class A, B, C, and D. So no other extinguisher can interact with the, means class A, B, C cannot be used on D, and D cannot be used on A, B, C. So whatever the extinguisher, each and every agent has its own properties. When we'll be discussing about section 17, in which we have various different types of extinguishers, carbon dioxide, dry chemical powders, wet chemicals, dry powders, foam systems, there we will see that how this type of fires can be controlled. Okay, so usually, all in all, what I want to say from the stoichiometric mixture, it gives us a base of understanding how a chemical chain break reaction can occur. Okay, or it serves us the purpose of understanding the tetrahedron of the fire. Okay, so fire can be propagated in 4 ways, and in the same way, it can be extinguished in the 4 ways. Okay, so let's see that. Or also known as theory of extinguishment. Okay, theory of extinguishment. 4 ways in which we can propagate, we can extinguish the fire. First is removal of oxygen. Then providing cooling effect. Third, by fuel separation. Fourth, breaking chemical chain. Right? In these 4 ways, we can provide extinguishment. Removal of oxygen is usually done by carbon dioxide and is also done by water. Water converts to steam. Steam displaces oxygen. Cooling effect. Water has the highest heat of vaporization, okay, values, then 4 times higher than any other non-flammable liquid. So it can absorb maximum amount of heat. Other also extinguishing mechanisms like dry powders, they can absorb large amount of heat. Okay, foam systems, they can also provide a cooling effect. Sprinklers, they can provide a cooling effect. Then fuel separation, blanketing is a type of a fuel separation, providing a blanket over top or directly interacting with the fuel. Dry powders, any type of powder extinguisher does that. Carbon dioxide does not do it because carbon dioxide does not leave any residue. And breaking chemical chain reaction, the last one that we were discussing, that sometimes we have to break the molecules, free oxygens that are coming out from the material itself. Some of the metals, okay, or some of chemicals, they tend to under combustion stage, they tend to give off free oxygen atoms continuously. Oxidizer. So let's say if I apply carbon dioxide on the top, now carbon dioxide has only one prime mechanism, that is removal of oxygen. The second is cooling effect, but that is secondary. The prime mechanism that we use carbon dioxide is for because of the removal of oxygen. So if I apply carbon dioxide on the surface, what will happen? Flame will disappear. Why? Because from the surface, the oxygen is not available. Flame will disappear, but again, the flame will reappear. Why? Because carbon dioxide is a surface-based extinguishment, right? But this oxygen is coming from inside the metal itself, from the chemical itself. So I need to actually break the chemical chain reaction within the chemical itself, okay? So that this free release of oxygen is not available, okay? So basically, this is the chemical chain break reaction that we want to do it. We want to convert the oxygen that is being produced from within the chemical itself, within the material itself, fertilizers, okay? I want to convert them into a product that will help me in creating extinguishment. Most of the time when we are using dry chemical powders on certain materials, you will see that after when we are removing the dry chemical powder, moisture, water accumulation is there. It's completely wet. Why? Because it has converted the oxygen and it started a formation of water molecules. Okay, so that is the breaking of chemical chain reaction. Now in this era where we have various different chemicals that are composed together to form a product, okay, that product can be more durable, it could be more reliable, more stiff, more hard, more usable. But in making of that product, we are introducing certain chemicals which the firefighter community may not be also aware. Okay, so but this becomes challenging when firefighting comes. Okay, when you're about to integrate with them, when you are about to deal with them in a real manner. There, these challenges are being faced by the firefighting. Okay, there we have no idea how. Sometimes we are applying the appropriate extinguishing agent based on our information, but instead of providing extinguishment, it's propagating. Okay, so that becomes more and more challenging, and especially in a confined spaces, like for example, if this room, okay, I'm providing a wrong agent for the time being. Okay, so what will happen? The propagation will be trapped. Okay, pressure inside the room will increase. Suddenly a blast will come. The windows cannot have hold that much amount of pressure. So sometimes we see that, okay, we are applying water. Okay, and there is an but applying water without creating an opening can also increase the internal pressure. Okay, so that is why sometimes the firefighters, they have to break out the windows. Okay, because when you are applying water in a closed volume, what will happen? Water will convert to steam, and water accumulation of the steam generation is going to be too much high, and that will increase the internal pressure of the facility. Okay, so for that purpose, we have to create an opening before applying a water. Okay, sometimes the firefighters wait out, so that the opening is usually created by themselves due to the fire effect. But if it is not being done, okay, for a considerable amount of time, they try to make an opening so that the heat is being released, pressure is released, then the water is applied. Okay, so basically what we are trying to do here is that we want to make sure that an appropriate agent is applied, and that appropriate agent, okay, has to follow some specific guidelines of NFP101 when we are talking about the residential occupancies. Okay, and when we are talking about business occupancies and everyone, NFP101 has some very strict guidelines. What type of furnishing you are going to use, what should be the radiant flux of the furnishings, how much radiation it should give in the environment. We will discuss slowly and gradually. We'll move on towards human factor, NFP101. Okay, and what type of opening should be there, what should be the width of the corridor, how many people should be there, how you will calculate the each exit floor capacity. Okay, so based on that, NFP 101 has some very strict regulations, standards, so that this all fire propagation, all fire extinguishment method becomes easier. Okay, anyways, theory of extinguishment considers us with four very good options. Okay, removal, oxygen, cooling effect, fuel separation, and breaking chemical chain reaction. But there is one more technique also in the extinguishment process. Sometimes we want same like a cathodic protection. Okay, we want a more flammable or more you can say more yeah, flammable material available inside an occupancy, so that your flame, rather than directed towards other materials, is directed towards the more flammable material inside an occupancy. Okay, so we'll take one example and we'll try to discuss that also. Yeah. Like for example, let's say if I have a company, okay, and my factory, let's say, has three very important assets that are available. Now, these are the core assets of my organization, meaning that the most of the production, 80 to 90% of the benefits that I'm going to produce, or my company that relies on three very important machineries, three important assets of my factory, right? So now let's say if a flame appears on one of the machinery, okay, what will happen? If a flame appears here, eventually heat will rise. There's a possibility it will always go towards the next, and from the next to the other, right? So even though if I have any very effective fire extinguishing mechanism, but fire extinguishing mechanism we cannot always rely on. Okay, we always want a secondary mechanism also. Fire extinguishing mechanism is there, but still we want a secondary precaution. So what we tend to do is that we tend to have a type of a more flammable materials that are available near towards each machinery. So now what happens? Instead of flame directing towards that one, okay, this will conduct all the flame. Okay, attract all the flame towards it. It will remove all the vapors that are being generated from the machinery, and it will direct it out. So what will happen? Now it will give me more time to take action. Rather than the heat to be diverted uncontrollably throughout the environment, now I'm directing the heat towards a specific material. Okay, heat will be diverted here also, but eventually it will give me more time to take an severe action, because most of my flame is being directed towards the flammable material itself. Now these type of ducting, they are usually known as sacrificial ducts. They are usually composed of combustible polymers. Okay, these type of ducts, they are usually made of combustible polymers. Okay, and the purpose is that they will direct all the corrosive vapors. Usually we use them in the process industries where the vapors could be flammable, it could be toxic, it could be both. Okay, so all the vapors are directed from the facility outside of the organization. Okay, and they direct the flame also. So these sacrificial ducts, they are usually vertical or they could be horizontal both. Okay, so these ducts are known as, they are usually composed of combustible polymers. Okay, they are sacrificial ducts that we tend to install, just one of the other techniques in theory of extinguishment. Okay, where we can actually direct the flame towards a more combustible material that is available nearby. Okay, sometimes what happens, as I said, the extinguishing mechanism is installed there, but it may not be effective. Why? Because in a process industry, you will see that there are various types of obstructions available. So your mechanism, your agent may not be directly interacting with the material itself. Okay, so there is always a risk, there is always a holding time of the gas that will be taking like 5 minutes, 7 minutes, but during that time, okay, the flame can propagate. So to direct it to buy more time, what we tend to do, we tend to direct the flame towards the more combustible material. Okay, similarly, the way we do in our cars also, cathodic protection. Sometimes when your car is getting rusted, okay, so what we do, we take to the mechanic. What he tends to do, he gives the positive terminal of the body, the car body is connected towards the positive terminal of the battery. He provides the most easy anode to the body of the car, right? So what will happen there? All the rusting will go towards the positive terminal of the battery. After 6 months, 8 months, you have to change the battery, okay, because the positive terminal is completely rusted. Why? Because you have given a more conductive material than the car body itself. Okay, so it saves your car from rusting. So one of the cathodic protection that we will discuss in underground storage tanks also. Okay, so same phenomena, but what we want to do is we want to direct the flame towards the most combustible material itself. Okay. Theory of detection. Detection can be done in three ways. We have smoke, fire signatures. Fire signatures are smoke, heat, and radiant energy. These three are the signatures that usually come from the fire: smoke, heat, and radiations, right? So smoke, we have smoke detectors. Okay, and smoke is usually the very initial stage, much more quicker than heat. Why? Because heat requires a collective temperature of 57 degrees Celsius, or maybe 7 to 8 degrees Celsius per minute, depending upon the technology. Radiations are much more quicker than heat and smoke, because even a spark is detected by the radiant energy. Lighter spark, even though that spark is also detected by radiant energy. Okay, so smoke, heat, and radiant energy. These are the three signatures of fire. But we have gas detection also as a type of a hazard. Okay, and gas detection is used to detect any type of flammable, toxic, or prototype gases. And when I'm stating prototype means that the gas that has both the feature, toxicity and flammability. Yeah. Usually our carbonaceous fuels, hydrocarbons, they are both, like our methane that we use in our household. Okay, they are both, they are toxic and at the same time they are flammable also. Okay, so we use gas detection also. What are the phenomena for using a gas detection? We will discuss that. Okay, there are three elements, three technologies in which we can use that we'll discuss in the next chapter that will start detection and alarm. Okay, gas detection works on three principles. First is catalytic element, then we have semiconductor, and then we have the infrared absorption principle. Infrared absorption we discussed in the first lecture also, that most of the toxic gases they get absorbed in the infrared radiations, right? So these are the theory of detection. An overview of carbon dioxide. Carbon dioxide, okay, usually that is in the solid form. The solid form of carbon dioxide is known as dry ice. And that form of carbon dioxide occurs at minus 79 degrees Celsius or minus 110 degree Fahrenheit. Okay. Why I am mentioning the dry ice form of carbon dioxide? Why not this liquid and the gaseous form? Carbon dioxide is stored in which form? In the portable extinguishers. Solid? No. Liquid form, right? Why? Because we check the weight of carbon dioxide, right? And from the liquid form, when the carbon dioxide is when the hose is pressed, the needle is injected. It converts because of high pressure. It converts to a solid form. That is why you find out the white cloudy appearance outside. Intense pressure. Okay, gaseous form it has no color. Yeah. On the solid form, it gives you a white cloudy appearance. Okay, so that's why you'll see that if you want to see the dry ice, you'll just collect it from you just hang a cloth outside the hose and you press it. You'll see the dry ice you'll be collecting in there. So that's the dry ice form. That is why we are discussing the solid form of carbon dioxide, because in the extinguishing mechanism, when I said that carbon dioxide serves two purposes, the prime purpose is the removal of oxygen. The second purpose was cooling effect. A cooling effect. How the cooling effect? Because it's in the dry ice form. It absorbs the heat around it. Okay, so the dry ice form of carbon dioxide is actually important for the extinguishing mechanism to understand that how the carbon dioxide extinguishers they work. It is always stored in the liquefied form. That is why whenever the maintenance, as per NFPA 10 and 12, whenever we are doing the maintenance of the carbon dioxide systems, we usually check the weight of the carbon dioxide, right? If it's a gas, we will check the pressure only, because the pressure is the only thing that affects the gas concentration. Okay, gas should always be pressurized, right? So liquid form, that's why we check the weight of carbon dioxide. So that's for section 2, uh, basics of fire and science. Okay, we'll take some sample questions. I'll just ask them to print 2 copies. The online people, I'll just share the screen with them so that we can discuss some questions. But once the print is ready, then we'll let's start a new section. Now you guys are on the group, right? It's not there. Let's share questions on the group and discuss the answers there. Okay. Ah, they don't even give to me also, They will come here and feed it. So let her come. I will take the password from her. Why she's saying- I'll just, let's see if the projector works. Okay. 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 Let's discuss the questions. Okay. Question number one: ratio of mass of a gas to the mass of an equal volume of dry air at same temperature and pressure corresponds to, yes, gas specific gravity, right? Why? Because mass per unit volume is, yes, of course, density, but here you can see here, uh, they are specifically mentioning the dry air concentration. Okay, and dry air concentration is the gas specific gravity to identify the buoyancy. Question number two: the amount of a heat a substance absorbs as its temperature increases is known as, hmm? It is latent heat, of course, of gasification, but the definition is not for the latent heat of gasification, because whenever heat is absorbed, yes, specific heat, yes, okay, uh, specific heat. Why? Because whenever a material absorbs heat, its temperature increases. Latent heat of gasification is a terminology that is further used in latent heat of gasification. When a solid absorbs heat, it converts to liquid state. That is latent heat of fusion. When a liquid absorbs heat, it converts to gaseous stage. That is the latent heat of vaporization. And a solid combustible, when converts to a complete vapor stage, that is the latent heat of gasification. So all this is coming under specific heat, right? Okay. Yes, specific heat. Okay, a device that measures the temperature due to intensity of radiation from hot object is, Yes, Raji, you are right. It is pyrometers, right? Pyrometers are the one that only measure the intensity of the radiations. Okay. Then we have the next one. Okay. Sorry. Okay. Yes. Among these, which heat units are SI approved? System International approved. Which one? Watt and calorie? Yes, exactly. Raji is again the top. Watt and joule. Watt and joules are the SI approved ones. Okay. Joule, heat unit, heat raised by 1 degree. Watt, amount of energy released. These two are approved SI units. BTU and calorie are just a type of you can say offset of joule. Okay, so they are not approved SI units. Okay, next question. The process that involves the transfer of heat by a circulating fluid, either a gas or liquid, is convection. Yes, okay, it is convection. So atoms that contain same number of protons but different number of neutrons are called, yeah, yes, isotopes. Exactly. Okay, the sum of atomic weights of all atoms in its molecules is called its sum of atomic weights of all atoms in its molecule. Molecular weight, right? It is, yes, it is the molecular weight. Okay, it's not the atomic weight, it is the molecular weight. Okay, because when we calculated the molecular weight, we see a C3 H8. Okay, so atom 3 into carbon and 8 into hydrogen, right? So that is the molecular weight. Okay. Oh, sorry. Back screen. Okay. The flame in which fuel and air are intimately mixed is, that is premixed flame. Exactly. That is the premixed flame. Next question. Vertical, horizontal ducts that exhaust or transport corrosive vapors in process industries are often composed of, yes, combustible polymers. Exactly. Yeah. Okay. Um, chemical decomposition. Oh, sorry, I think we have missed one page. No. Okay. The chemical decomposition of a material into one or more substances due to heat alone is, yes, stoichiometric, in which we have fuel and oxygen available, and once the chemical reaction completes, all fuel is consumed, no oxygen is left. And in the first introduction, we discussed about heat release rate. The material undergoes an heat, and whenever a material undergoes an heat, okay, what happens? It changes its state. Okay, and a professional is the one who understands what is the byproduct that it's always going to change. So that is the process of pyrolysis. Okay, in pyrolysis only we tend to know what are the byproducts. One, from the byproducts we can know that, okay, this material is going to give me a byproduct. That byproduct is a toxic vapor that is going to be dangerous for my people. Okay, so it doesn't mean that I'm only going to provide extinguishing for the flame. Now I need a ventilation to make sure that the byproducts are also cleared out, right? So that is pyrolysis. Okay. Thermal inertia is a product of three physical properties. Sorry. The first topic that we discussed, maximum burning rate. Okay, we discussed three very important things in that one. First of all, if whenever a flame appears, the flame is going to divert the heat towards the material itself. And this component is going to be true for each and every material. Okay, maximum amount of heat transfer is usually done by the convection energy, if you remember in the heat transfer mechanism that we discussed. right? So heat transfer per unit of an area. So I can say density is the one that is, of course, there. Okay. Second thing is that the capability of the material to conduct the heat. We gave example of steel and glass. Steel has the capability to sustain, right? While the glass does not have. It means conductivity is the second important parameter. And the third, if you remember, was the mass. If a single sheet of paper, it will consume very quickly. If I have a bundle of paper, it will take much more time, okay, to consume. So that's the thermal inertia, density, conductivity, and heat capacity, okay. Similarly, related towards the maximum burning rate, the next question, the amount of heat released by a fire per unit of time depends on its amount of heat released. Now it's not about the conduction. Now it's at a stage where the material has already started exothermic reaction. So heat release. Yes, A only is the right answer. Why? Because heat release per unit of time. Okay, so it means the combustion heat release, mass of fuel, the mass is larger, the more heat will be there, and efficiency of combustion. Yeah. Solid form of carbon dioxide, commonly known as dry ice at atmospheric pressure, exists only below Fahrenheit is -110. In the exam, both the values will be given, -79 and -110. Okay, so both values will be given, right? Yes, it is -110. Water has high heat of vaporization. How many times higher than any other non-flammable liquid? Yes, yes, Ibrahim. Just now I mentioned it. How many times higher than any other non-flammable liquid? It's 4 times higher than any other non-flammable liquid. It has the highest heat of vaporization. Which wavelength has the lowest values? No. Cosmic rays. Yes, exactly. Cosmic rays has the lowest values. Exactly. Yeah. Moving on towards the next question. Symbol Q loss. Again, from the first topic, maximum burning rate, we had Q flame, Q loss. The symbol Q loss represents yes, exactly. So what happens that we discussed in the maximum burning rate. Now, formulas are not part of the examination, but abbreviations can be. So like this, they can ask you a question in the exam. So now Q loss represents, if you remember, we discussed two terminologies from flame, heat loss from flame to the material. That was Q flame. Okay. And from the material to the surface, that was Q loss. Okay. So heat loss through the surface. Okay. That is Q loss. Okay. Values of heat of gasification are usually quoted in units like yes, exactly. Kilojoules per kg, right? Kilojoules per kg. Okay. We have been discussing about heat of gasification values, right? Wow. Latent heat of fusion of water, 333.4 kilojoules per kg. Right? So, sorry. Which of the following pair of temperature units are not considered as SI units? Are not considered as SI units. So we had 4 temperature units: Celsius, Kelvin, Fahrenheit, and Rankine, right? So Celsius and Kelvin are approved SI units. Fahrenheit and Rankine, they are not approved as SI units, exactly 4. Okay, moving on towards next. During combustion, heat always transfers from higher to lower temperature, right? To form the state of equilibrium. Yes. The major cause behind fire promotion and spreading process is all of above are is the right answer. Okay, the major cause behind fire promotion, all of above. Okay. Okay. We are going to start our next section. Okay, that will be section 14, detection and alarm. Why we are going towards section 14 from section 2? Okay, we could have gone for analysis of fire protection, human factor in emergencies. Okay, then we could have gone to section 14. But basics of fire and science. Okay, whatever the things that we have discussed. Okay, after all these sections, when we will reach in section 14 and 17, you will forget all these things. So these all are related to each other. Now we have discussed about the theory of extinguishment. Okay, it will help us in theory of for section 17. Okay, because after theory of extinguishment, okay, if I'll directly go for carbon dioxide dry chemical powder, dry powder, it will be coming directly into your memories. Okay, it was easy to approach the exam like that, approach your study also like that. Okay, from basics of fire and science. Okay, the major cause that we have discussed is the fire chemistry, heat release rate, smoke development ratio, flame spread index, extinguishment detection. So why unnecessarily then I will go for topics that are not interrelated with each other. Okay, so now we have discussed about the theory of detection also. So here, from here, we'll move on towards the detection. Okay, then we will go on towards section 17, that is extinguishment. Then we will move on towards section 16, that is water-based systems. Okay, so why we are doing this? First of all, the weightage is also great, higher. Okay, and then the second thing is that they are interrelated with each other. So you will see here, whatever we have discussed in basics of fire and science about bimetallic expansion, about the thermocouples, it's going to be repeated here. About the infrared absorption principle, again, it will be repeated here in this section 14. So it will become easy for you to memorize and cover the topics also more easily. Okay, so we are going to start from section 14, that is detection and alarm. Section 14 of the Fire Protection Handbook. Okay. Why do we install a fire alarm system? The purpose of the fire alarm system, or the topic name, detection and alarm. Okay. The purpose of a fire alarm system is to provide audible, visual notifications for the occupants so that they can evacuate in a timely manner outside the occupancy. That is why we will always focus that an appropriate fire alarm detection system should be there in any occupancy. Whenever we install a system, it always has its protection goals. Okay, the detection and alarm, okay, or the fire alarm systems, okay, they have their protection goal. The first goal that we want to achieve, okay, is the life safety of the occupants. That is the most common one. Any fire protection system, the first goal is the life safety of the occupants. We have discussed that before also, right? If I want to just only, if my focus was only the property, okay, I don't require to have sprinklers. I will just have high jet stream water spray nozzles attached. Okay, and I can completely flood the whole occupancy. Okay, and that's what I do. Wherever I have explosive industries, where I have weapon industries, okay, explosions, bombs, TNT, black powder, wherever I am storing them, I'm doing the same thing. Even a small spark appears, the complete area is flooded with water. Okay, ultra high speed water spray systems. I do it. Why? Because there the property protection is very important. Okay. Similarly, whenever I'm going to install any type of fire protection system, the first purpose is the life safety of the occupants. The second protection goal is the property protection. Okay, then comes the property protection. Okay, and the third is the mission protection. In the examination, a question like this came. Okay, and it is also in our sample questions also. The protection goal for a fire alarm system embraces three important goals, except, and they give four options: life safety, property, mission, and insurance protection. So insurance protection is an exception. Okay, so like this, they can include a question in the exam. Okay, so that's why it's very important to understand the three protection goals. But what is your mission protection? Any ideas? Life safety, okay. Property, your monetary protection. What is your mission protection? It indicates that my own goals that I want to achieve, they should be the least priority. Okay. For example, I install a system. I wanted some specific goals. Whenever a fire professional is being handed over a project, okay, what are his goals? My goals are the efficiency of the system. Okay. Efficiency of the system, reliability of a system. Okay. Why? Because these are now associated with directly my performances. Okay, so these are my goals that I want to achieve. That in case of fire incident, did my system operated appropriately? Did the occupants evacuated, okay, effectively? And my system sustained or worked for a time that was much more longer than expected. So these are the goals that I want to achieve when I'm installing a system. So these are the least priority. Top priority are the first priority is the life safety, then the property, and then comes your own priorities, your own missions, your own goals that you want to achieve. Okay, that is the third. That is the mission protection. In the fire alarm system, we usually have signals that are available with us. Three types of signals are there. Okay, the first signal is usually an alarm with a red identification. Usually, a red light it blinks in the fire alarm control panel. When this light blinks, it indicates that any type of an hazardous situation has occurred. Meaning, any of my initiating devices has operated, whether my smoke detectors have operated, whether my manual brake glass is operated, sprinklers have been operated. So a red indication will be there. Okay, indicating a threat is there. Okay, the second type of a signal is a supervisory signal. A supervisory signal always appears whenever an attention is required of a trained personnel at the system. For example, I have an occupancy. I want to do the maintenance and testing of the system, of the fire alarm system. Okay. So I approach to the control panel. I cannot randomly just start doing the testing and triggering the alarm throughout the whole building. First thing is that I have to put my control panel in the testing mode, right? So once I will put it on the testing mode, a supervisory signal will appear that either a trained personnel is working on the system or his attention is required at a control panel. So this supervisory signal will appear. Okay. For example, my main valve, OS and Y valve, okay, of the sprinkler system, it should always be open. In the normal, in a wet system, it should always be open. Okay. So if an abnormal operation is there, means it is in a closed position, a supervisory signal will appear, indicating that the valves is in an abnormal condition. So an authorized or trained personnel is required at a control panel. So that is what a supervisory signal is all about. Then the third type of signal, third signal is a trouble signal. A trouble signal always appears whenever there's a fault in a monitored circuit. Whenever there's a fault that appears in a circuit, a trouble signal appears. Okay. According to the NFP72, most of the faults that appear in the detectors, okay, usually the detectors, they are having a series connection in conventional and a parallel connection in a addressable system. So the most of the failures of a fire alarm system, usually the trouble signal comes is because of the conductor breakage. Okay, the conductor breakage. Okay, this is the most common type of a trouble that usually comes. Okay, so in the examination they can ask you a question that the most common type of common failures of a fire alarm system includes, and they can give you four options like detector electronic fault, detector faulty, manual break, glass broken or something. So the highest number of failures is because of the conductor breakage. Okay, now the conductor breakage could be at both end, either it could be in the distribution end or at the terminal end when you are connecting it too much tightly and the cable is bending, so a conductor breakage could be there. So conductor breakage is considered as one of the most common and highest rated failure that usually appears in a fire alarm control panel. So a trouble signal indicates a fault in a monitored circuit. Okay, the most highest number of a fault is usually associated with the conductor breakage. Okay. Moving on, let's see that what are the different types of components that are available in a fire alarm system. So in a fire alarm system, the major components includes a control unit that defines the operations of the system, how a control panel is going to operate, conventional and addressable that we tend to usually design accordingly. Then we have a primary power supply. That is usually the power supply from the authorities, right? SEWA, in our case, DEWA, okay, electricity and water authorities, okay. So then we have the secondary power. What is the purpose of secondary power? Primary power failure, secondary power should be there, right? So secondary power. Okay, then we come on towards the circuits that are available inside the control panel, in which we have the initiating device circuits. We will discuss these also. Then we have a signaling line circuits. Okay, and in the last, we have notification appliance circuits. Like our sounders, our flashers. So they are notification appliance circuits. Initiating device circuits, signaling line circuits, and notification appliance circuits. Initiating device circuits indicate a type of a circuit in which when a device operates, the whole circuit initiates. Okay, when a single device operates, the whole circuit initiates. We will discuss that in a conventional system. We will see that how a device operates and the whole circuit initiates. So that's an initiating device circuits. Signaling line circuits means a two-way communication. Okay, a two-way communication could be in any form. It could be you connecting your laptop from an RS-232 cable with a control panel. That is a signaling line circuit. A signaling line circuit could be a communication from a control panel to the detector, and from detector back to the control panel is a two-way communication. It could be a signaling line circuit. Okay, so just to establish a two-way communication, okay, that is a signaling line circuit. Notification appliance circuits, your sounders, okay, your bells, your visual, audible notifications. There are all your notification appliance circuits that tend to provide a certain amount of sound level so that people are aware of it, of the threat, and they can evacuate the occupancy in a short time. Okay, so that's the notification appliance circuit. What NFPA 72 says is that whenever there is a primary power failure, the secondary power should take over within 30 seconds. This is the requirement by NFPA 72. That whenever there is a primary power failure, okay, your authority power fail, within 30 seconds, okay, the secondary power should take place. Usually in the fire alarm control panel, what is our secondary power? Batteries, why battery is 30 seconds? Why this clause is there for 30 seconds? Milliseconds, the battery will shift power, right? Why 30 seconds? NFP 72 says 30 seconds, within 30 seconds. Exactly, because NFPA 70 defines that the secondary power is not only batteries. There are 5 energy sources that are secondary power: generator, battery, UPS, separate equipment, unit equipment. These are the 5 energy sources we will discuss later on in the facilities fire hazard management in complete detail. Okay, your generator takes 25 seconds to normalize after operation. 28th second, 27 to 28 second, it shifts the power. Okay, it shifts the power towards the primary load. So that is why secondary power is given within 30 seconds. When this question comes in the examination, okay, most of the students in the start, I never used to give any priority to this type of a question. Okay, but sooner or later, when I added this question in my sample questions, I realized that most of the people, they always go for the least time. Okay, if I'll write 30 milliseconds, they will go for the 30 milliseconds because everyone is assuming batteries. Okay, so basically NFP 72 says that 30 seconds is because keeping generator also as a secondary power in mind. Okay, so whenever your primary power fails, the secondary power should be taken within 30 seconds. Now this type of question can come in the examination. Okay, now it's a type of a code, it's a type of a standard, but as well as with the code and standard, it's a type of a source of information also. So that's why this type of questions are important in the examination. Okay, so let's have a quick view of the initiating device circuits, signaling line circuits, and based on that, we will see that what NFPA 70, National Electric Code, defines these circuits as Class A or Class B circuits. Okay. Because in the examination, they may ask you the type of a circuit which operates up to a single fault, and then they will give you A, B, C, D. Okay, so like this, we can memorize it, but we are using these circuits in our control panel. So it becomes much more easier for us to understand, and no need to memorize it. Then we can understand that, okay, in this system, we know it's this category of a circuit is there. So in a fire alarm control panel, okay, any fire alarm control panel, if the control panel is a conventional type, usually we have a series connection. Means all the detectors, they are operated, they are connected within a series, right? At the end of a detector, we have a very high resistance known as end of line resistance. EOL, end of line resistance, right? Okay. Each detector, it is connected in series. Okay. So the problem with this type of a system is that once a single device operates, okay, the whole circuit will operate. Okay. It only requires one normally close contact. That's it. And the whole device will operate. The problem here is that I don't know which detector has operated. I know only this specific zone has operated. So I will go to the first detector, second detector, third detector. Eventually, I will go to the detector that is operated. So it's time consuming for me to do the surveillance. So these type of a circuit, okay, in which a device operates and it initiates the whole circuit, initiating device circuits. That's why we say our smoke detectors, our brake glasses, our sprinklers, zone control valves, butterfly valves, okay, they are all initiating device circuits because once they operate, the whole circuit operates. Okay, it sends directly, it initiates the circuit and sends a signal directly to the fire alarm control panel. The problem, next problem with this type of a circuit is that if there's a conductor breakage anywhere, what will happen? The whole circuit disables, right? So it means it operates up to a single fault, right? If a single fault occurs, the whole circuit disables. So NFPA 70, the National Electric Code, NEC, defines this type of a circuit which operates up to a single fault as class B circuits. Okay, they define it as class B circuits, the circuits that operate up to a single fault, meaning that as soon as a single fault appears, the whole circuit disables. Conventional systems are very effective for those areas where we have less small areas, 1 room, 2 room, shops. Okay, so there a conventional system is of course a cheap, okay, and a very cost effective solution. But in high-rise buildings, these systems are not effective. That is why their use is now discouraged in any high-rise buildings. In high-rise buildings, we need to have much more quick surveillance. Okay, so this is for the initiating for the conventional system. Now, what happens in the high-rise building? Two problems are here. First of all, the conductor breakage, the whole circuit disables. And second thing, the surveillance time is far more greater, right? If I have more and more detectors, more surveillance time, more time to reach towards the point of fire. So for that purpose, to deal with these two problems, I go for the next type of a system, okay, that is addressable systems. In the addressable systems, what I tend to do is that I have more like a parallel connection. Okay, and the last detector is coming back directly towards the control panel. Now, what happens in an addressable system? If there is a conductor breakage, what will happen? The detector, only one detector that is being affected will be done. Other are still getting the, other are still operated. Okay, a type of a ring circuit. We have 13 ampere sockets, right? Ring circuit. If one circuit short circuit is there, other will operate. This only the circuit will disable. Similarly, if a fault appears, only that detector will disable. The other will continue operating. Okay. Second thing is that the detectors that we use in the addressable systems, these are programmable detectors. I can provide them a coding, specific coding. By a handheld programmer, I can provide it a coding of 1, 2, and 3. And now this coding is being directly given to the control panel. It stores inside it. Okay. I can change these numbers to alphabets by using a program defining tool. I can change this 3 to kitchen, 2 to garage, something like that. I can change these numbers. Okay. So now what happens? As soon as the detector operates, what will happen? The information is carried directly to the control panel. The control panel displays that your detector in the kitchen has operated. So I don't have to go anywhere else. I will directly go towards the point. So my surveillance time is also reduced. Okay. So control panel is communicating with a detector. Detector is sending the information back to the control panel. So a two-way communication is taking place. This can also be regarded as one of the signaling line circuits. Usually communication that you want to do. Inside the control panels, we have the RS-232 cable ports usually available. Okay, specifically used to communicate with a control panel. That is also a signaling line circuit, a two-way communication in from the laptop where you can communicate with a control panel. So when I'm using the defining tools, what I'm trying to do, I'm using a signaling line circuit. I'm trying to communicate with the control panel to provide it more information regarding the devices. This type of a parallel circuit, okay, this type of a parallel circuit, a ring circuit in NFPA 70 National Electric Code is stated as class A circuits. They are known as class A circuits, the ring type of circuits. Okay, where a single fault, okay, only affects the next device rather than disabling the whole circuit, a type of a ring circuit. Okay, so this type of a circuit in NFPA 70 National Electric Code is known as class A circuits. So the concept of initiating device circuits includes all our devices. Okay, these all are initiating device circuits. Okay, where any circuit, wherever I have my initiating devices, my smoke detectors, heat detectors, radiant detectors, they all are initiating device circuits. And anywhere where I have a communication buildup with the control panel, that are my signaling line circuits. Okay. Then based on that information, what we have discussed, okay, and about the fire alarm systems, conventional addressable system is the type of installation that we are doing in the systems, right? But based on the signals that are available within our systems, fire alarms, okay, we have 5 different types of systems available. Alarm signals, okay. The alarm signals can be relayed or can be given to a specific authority, can be given directly to a civil defense, can be within the building, okay, where I want to extend the alarms. Based on the alarms, okay, where I want to extend the alarm, okay, based on the alarms, I have 5 different types of systems available with me, okay. The first type of a system, okay, in which the fire alarm control panel initiates an alarm, okay, and that alarm remains within the building itself. Usually, most of our buildings, what happens? The control panel shows an alarm, and the watchman or the security, he is only looking at a control panel, right? It remains in the building. Means the security looks at a control panel, he finds out there is an alarm, okay, and he investigates it. If he feels that okay, there is some issue, means I need assistance, I need external assistance from the civil defense, then he can make a call, okay. So this type of a system is known as a protected premises system. Okay, that is a protected premises system, okay. The alarm remains there and the security is the one who notices the alarm, that's it. It's not going anywhere else. The alarm remains within the building. Most of our buildings are the same, okay. They are the protected premises system. The second type of a system in which the fire alarm control panel provides an alarm, and that alarm, okay, is being monitored by any third party, okay. And what do I mean by third party is that I don't involve directly the civil defense or the owners, okay. Like for example, let me give you example of Dubai Mall. Dubai Mall is monitored by IMAR. Now, any of the fire alarms that will appear in the Dubai Mall, okay, the alarm will go directly to the IMAR Fire and Safety Department. IMAR and Fire and Safety Department have their own first responders that will respond to it. Once they respond to it, and if they find, okay, we need as external assistance, then they can call the civil defense, okay. So there is a station in between, the premises and the authorities, okay, a third party. So this type of a system is known as central station system. The third type of a system, you have a control panel, alarm is initiated, and alarm is monitored by the property owner within the same property, okay. For example, I have tower A, B, C, and D. Now I have 4 towers that are available with me, okay. On all these 4 towers, what I want all the alarms to be connected towards the main building. Here I have one master control panel, and this master control panel is monitoring all the small control panels. Anything happens in A, B, C, okay, what will happen? The alarm will appear onto the master control panel in the D, okay. So it is being monitored at the same property owner, means that all the buildings are from the same property owner, okay. So he is monitoring the alarms directly, okay. So this type of a system is known as a proprietary system. Alarm being monitored by the same property owner, okay. Like if I want to give a more clear example, BMS, usually most of the buildings have their own BMS system, right? So they are continuously monitoring, okay. And if they feel that okay, there's a threat and this threat requires an external assistance, then they will involve authorities, Okay, you can see here, in any of these systems, I'm not involving the authorities directly. Okay, none of these systems is involving the authorities directly. There is a condition, and after that, if the authorities are required, then they can come. Okay. The fourth type of a system, okay, in the fire alarm control panel, alarm initiates, and the alarm is sent to a remote location. This type of a system is known as a remote location system. Now, where do I use a remote location system? Remote station system or location system? Where do I use them? Usually, I have some of the industries that are not allowed to be established near towards the city. They are a very remote location. You'll see here, most of the oil and gas industry, you'll see they are far from the cities. Inside, in somewhere in middle of the desert, you'll find some industries, okay, where gas processing is there, gas filtration is there, any other chemical processing industries. So they are far from the cities. Now, these facilities, they also require some type of protection, right? So if there is any type of a hazard, they have their own teams available. They will first of all initiate, and if at the same time they want, they can send an alarm directly towards a connecting point in between, because these are very far from the cities. So the civil defense is also far from them. Okay. So what they tend to do is that a facility, okay, what it has to do, it sends an alarm to a remote, any type of a remote location. A remote location could be any type of a shop, it could be any type of a nearby facility, any type of showroom, any building structure that is operating. Most of the time it is sometimes as a police station or even a type of a military base also. So it sends a signal directly to them. They receive the signal and record that signal, interpret it, and then they directly send it to the civil defense. So from there, the signal is sent to the authorities. When they are at a very far location from the city, from the civil defense. So they need a type of a stop point. Usually military bases or police bases are there. So a location is sent to them, and from there it is sent to the authorities. Okay, so this type of a system is a remote station system. The only system that sends an alarm directly towards the authorities, usually we have these boxes also, 24/7 boxes. Okay, the only system that sends an alarm directly to the authorities is an auxiliary system. Usually you'll see that in most of our facilities now in Dubai, okay, they all have 24/7 boxes. Now in Sharjah also, a new project, Aman, has started, and they have also started with the same 24/7 boxes. Okay, any alarm, any fault is there, Aman will receive it. So fire alarm directly sending a signal to authority is the auxiliary systems. NFPA 72 says that either whenever it's a protected premises system, central station system, proprietary system, remote location system, or auxiliary system, all of these systems, as per the NFPA 72 requirements, okay, they all should have 24 hours of standby power, followed by minimum 5 minutes of alarm. Followed by minimum 5 minutes of alarm. Okay, they all should have 24 hours of standby power supply. Okay, and minimum 5 minutes of alarm should be there. Okay, mean in case of any type of a scenario, your fire alarm system should be well protected in such a way that any hazard cannot affect it accordingly. It should be protected in such a way. Okay, so that minimum 5 minutes of alarm should be given either to a third party, to property, anywhere, but minimum 5 minutes of alarm should be there. Okay, so this is the condition for NFPA 72 for these systems. One of the systems that we have other than these alarms are the evac systems, emergency voice alarm communication systems. In other words, we use evac systems, emergency voice and alarm communication systems. Any ideas where do we use the systems? Usually we have speakers available, right? Hmm? Them, yes. Where do we use them specifically? If my alarm bell is going to provide me the same notification, why do I need an evac system? Mm. Like my all buildings, residential buildings, they have alarm bells, right? If the alarm bell is ringing, that is also a signal that I need to evacuate. Okay, it serves two purposes. Okay, for to understand the purpose, we have to go back to the history, because it's not a type of a specification based code. This evac is a performance based code. And performance based code means that based on the performances that are affecting the fire systems or the evacuation strategies, okay, a specifically requirement is being established. 1993 fire explosions, World Trade Center. Sorry, 1993 fire explosions. Okay, what happened? And the World Trade Center, people wanted to evacuate. Okay, two things happened. First of all elevators were continuously running. Okay, whenever a fire incident will occur, what will be the first thing? The authority power will disconnect. Authority power will disconnect. Either it will disconnect because of short circuit, or the security or the authorities will disconnect it, but they will disconnect it. The authority power is the first condition that has to be disconnected. We don't want further short circuits and further flame incidents there, right? So the authority power is disconnected. A lot of people from all the floors, they all wanted to evacuate, of course. Okay, so staircases jammed, elevators filled up, power loss is there. What happened? The elevator stalled. A lot of people died inside elevators. The staircases, okay, people fall down due to vibration, okay, shaking of the building, stampede situation occurred. Okay, some doors were blocked, fire was there, the people were trapped there also. So what happened? A lot of people trapped in the same staircases. Then the firefighters that were actually trying to reach towards the higher floors to rescue people, their communication with the team was also out of the range. Okay, the wireless communication of the team was out of the range. So if they required any type of an external assistance, it was not possible for them to communicate directly. Okay, because they were out of the range, and because of that, a lot of firefighters also died. Okay, so all in all, the evac system was introduced to cover two very important, two major problems. The first problem, okay, from the name itself, is to establish communication. Okay, establish communication, okay, among the firefighters. And you will see that each and every evac system, at a specific floor, they have the firefighter module. And what is the firefighter module? He can plug in his device. He can use the same speakers to communicate with the ground floor. Okay, so that if he is at the 70th floor also, or 100th floor, okay, he can just plug in his device. He will communicate with the ground floor that I need this assistance at this floor. Okay, or I'm trapped, or I need assistance, life safety, or whatever the hazard is there. So first thing is to establish communication. Second thing about the emergency voice. Now here the voice is there. The second thing is to provide instructions for the people. Okay, Instructions for the occupants to evacuate in a timely manner. Like for example, let's say a 50th floor building is, and this is a 50th floor building, okay, and fire has somewhere started at the 10th floor. Fire and heat will always propagate on towards the upper floors, right? So if a fire has started on the 10th floor, so it is not, I mean, I will not allow all the occupant to come into the staircases. I want them to evacuate in phases. Okay. So first of all, the people that are near to the threat, they will be evacuated. So my voice, emergency voice, will give instructions. Five occupants from 5th floor to 15th floor proceed towards the exit staircases. Okay. Evacuate from the building. People from 1 to 5, okay, please move towards a refuge room, or if you find a safe passageway, exit the building. People from 49 to 25 floor, no need to evacuate. Stay in the refuge rooms so that you are not congesting the whole stairways. So you want to give instructions to the occupants. Okay, that okay, so that in phases you can evacuate the people. All in all, I'm just talking about a 50th floor. We know here we have 150 floor buildings also. Okay, so all in all, if I want all the people to evacuate on a staircase, the evacuation time will be far more greater than 1 hour. It is going to go 1.5, 2 hours also even. So if a stampede situation occurs, then more worse scenarios. Okay, people are trapped. So for that purpose, I need to give them instructions. So that is the purpose of a evacuation, evac systems. Okay, emergency voice alarm communication systems. Okay. Now, NFPA 72 says whenever you have an evac system, okay, the evac system should have 24 hours of standby power, same as our other systems. Okay, followed by 2 hours of emergency operations. Rather than 5 minutes of alarm, 2 hours of emergency operations, meaning that your notification appliances, 2 hours. Your wall ratings, 2 hours. Your door ratings, 2 hours. The water available inside the sprinklers, 2 hours. So all your operations, all emergency operations, whether it's firefighting, fire detection, evacuation, all this should be minimum of 2 hours of fire operation should be there. Emergency operation should be there. So this is the requirement for the evac systems. So in the examination, they can ask you any of the system. Simply, they can say that an assembly occupancy, a type of a protected premises system, okay, requires 24 hours of standby power, and the other condition by the NFPA is, and they can give you options, okay, and the other condition is that minimum 5 minutes of alarm, but only in the evac system, okay, you require 2 hours of emergency operation. Whenever we are talking about an evac system, it means we are talking about high-rise buildings, not mid-rise, not low-rise. We are talking about high-rise buildings, okay, where the evacuation time is far more greater than 1 hour, okay. So there we need to make sure that we have an evac system, and it should have a 2 hours of emergency operation. 24 hours of standby power should always be there, okay. Okay, let's just take 10-15 minutes break. Then we'll be back. We'll discuss about detectors, smoke detectors, heat detectors, and we'll see about the radiant detectors also. Okay. Hmm? We'll see 7, yeah, 6:30. We'll see. Want to go somewhere? Yeah, they will be somewhere. Yeah, that's it. And the admin is there. What? We will finish before it starts. Yeah, that's okay. 6 o'clock. That's why I'm not taking that much longer. Just continuously one so that we can say not only you, we have a lot of money. They want to make people. Yeah. From admin, Samir here. Yeah, he's also there. Okay. No issues. Where have you come from? Dubai? Yeah, only Charlotte. Charlotte. Same like me. I'm Charlotte. Oh, I'm actually in Pakistan. I'm working with Pakistan. Okay. Okay. There are some questions maybe. Okay. No issues. No issues. Yeah, yeah. Now it will be continuous. Yeah. Mhm. Ah, 8 to 9 classes. So maybe it can go up to 10 also, but it will be there. Yeah, maximum. My meaning that last end classes are usually for mock examinations. We discuss mocks. Like we'll take 70 questions, we'll discuss them live. Yeah. You can even because after the training, if you are doing preferably what like if you are following the training continuously, then after training you can go for the exam. Like we are sharing the study materials, right? You highlight the book, you're highlighting the book weekly, and then you are studying. Then as soon as the training appear finishes, you can go for the exam. But if you are actually if you're not following up because of your busy schedule, then you need 1 month to get familiarized with the book. Book familiarity is important. And yeah, we are providing the slides and notes. So use those notes to highlight the book. So it's not everything. Only important topics are there. So automatically you will know from where we are starting, and you will rush through the chapters like this. So there is unnecessary data that we have left out. Only the important points are there. So it will help you in filtering out the data. Okay, no issue. Okay. Yes. Yeah. Okay. So let's discuss about the detectors. Mhm. We have discussed 3 fire signatures, right? Smoke, heat, and radiant. Smoke detectors, they can be categorized into 3 types. Okay. Further, we have a photoelectric, ionization, and video. These are the 3 types of detectors: smoke detectors, photoelectric, ionization, okay, and video based detectors. Heat detectors can again be further categorized into 3 types. Okay, we have fixed temperature, rate of rise, and rate of compensation. Radiant detectors can be further categorized into 2. Okay, ultraviolet and infrared. Okay, so these are the five types of detectors that are available with us. Okay, and how we have to use these detectors we have discussed already, right? An effective detection leads towards effective notification, which can give an effective evacuation, right? So if any material has high heat release rate, so heat detectors, high smoke development index, okay, smoke detectors. Radiation, flame spread index, we will have radiation. So based on that, we have all these type of detectors that are available with us. We'll start with smoke detectors, then we'll move on towards heat, and then we'll discuss about the radiant detectors. One of the detectors that we have not mentioned here as a fire signature is the gas detectors. I mean, they are, because they are not fire signatures, because they are toxic, flammable, they could be, but they are gas detectors in detection, and we will discuss them separately. Okay, based on fire signatures, smoke, heat, and radiation. Okay, so let's start from smoke detectors, starting from the photoelectric detectors. Okay. Okay, smoke detectors, photoelectric type. Now, what happens in this detector? Usually, we have a source light, source, and a receiver. And this receiver is having a resistance, a type of a photocell or a light dependent resistance, LDR, or we say a photocell. Lights fall on it, resistance becomes lower, current flows, and the circuit closes. The source is actually throwing light away from the receiver. To understand the phenomena, we have to understand two important characteristics of the smoke. Smoke, whenever it is being released from any type of a material, it has its own particulates with it. That is why the smoke itself is shiny in nature. Okay, so smoke has two very important characteristics. First thing is that it is shiny in nature. Okay, it has shiny particulates. Second important thing is that because it carries the cryosides of other materials byproducts, it has deionization capability. It deionizes ions. So if we are going to use the first characteristic here, that is the shiny. Source throws light away from the receiver. Smoke enters into the chamber. Okay, what will happen? The light will reflect. And once the light will reflect, it will reflect towards the particles and eventually fall on the receiver. And when it falls on the receiver, okay, the resistance becomes lower, current flows, and it triggers an alarm. Now, this type of a photoelectric principle of the light of the smoke detector is known as obstruction of light beam. Similarly, I can use the same shiny nature to reflect the light away also. So I have a source and I have a receiver. Now this time the light is directly thrown at the receiver. Smoke enters, but as soon as smoke enters, what will happen? The light will be reflected. And now in this time, the light will be reflected away from the receiver. This type of a principle is intensity of light beam. Or we can also say in warehouses, we use this one as beam detectors. Okay, where the light source is directly thrown at the receiver. As soon as smoke enters, the light is reflected away from the receiver, initiating an alarm. So that is intensity of light beam. Sorry. So photoelectric principle, it works on two principles. One is the obstruction of light beam and the other one is the intensity of light beam. If I want to calculate, if I want to just understand the response time, okay, intensity of light beam will have a much more quicker response, right? Because in the obstruction of light beam, the light will reflect within the particulates and then it will fall on the receiver, right? But in intensity of light beam, what will happen? The light will suddenly reflect away from the receiver. So this is the photoelectric principle of the smoke detectors. Now I'm going to use the second one, that is the deionization. Okay. Yeah. Yeah, beam detectors intensity one. Yes, intensity of light beam is the principle on which the beam detectors work. Now I'm going to use the second property, that is the deionization. And I'm going to see what type of detectors I can use here. So in the ionization detectors, usually I have a radioactive element. A radioactive element means that it's an energy-free element, means free energy, a source of energy it's going to provide you whenever it's connected to a source. Okay. So this radioactive element that we tend to use in our smoke detectors are, this element is americium-241. And it is also known as an alpha emitter, means alpha radiations. Alpha radiations does not have that much of penetration. They are very weak radiations. They cannot penetrate even through a thin sheet of paper. So skin penetration is very, it's far more above its capability. So americium-241 alpha emitter. Now, what happens in this type of smoke detector? Okay, we have this radioactive element is connected towards a source. Usually, in case a power source, it could be battery. As soon as a power source is connected, what will happen? The radioactive element will start giving off energy, right? Energy in the form of ions into the atmosphere. Plus, minus, plus, negative and positive ions, it will start giving into the atmosphere. Within the smoke detector, we have charge plates available. And charge plates are, one is a positive charge plate and the other one is a negative charge plate. Okay, so we have a positive and a negative charge plate available with us. In chemistry, we have discussed this. Opposite attract, similar they repel, right? So what is going to happen here is that the positive ions, they are going to be attracted towards the negative charge particle, negative charge plate, right? And the negative ions, they are going to be attracted towards the positive charge plate, right? So this principle will go on for all the ions that are available, right? So in other words, I can also say that there is a flow of negative ions going on between the barrier. How do we define electric current? Electric current is the flow of electrons, flow of negative ions, right? So somehow what I have done here is that I have created a wireless current barrier, right? Wireless current is actually flowing continuously between the charge plates. And now this current is being measured, okay, at the back and within the circuitry. Okay, this current is being continuously measured. Okay, now what happens here at this point? Whenever a smoke enters into the chamber, okay, it creates a blast of deionization. Means as soon as it will enter into the chamber, it will blast off the ions into various directions. Okay, so the positive ions will be gone here, negative ions far from the charge plates. So ions will be flowing in all various directions away from the charge plates. Okay, not near, away from the charge plates. So what will happen? The negative ions will not start flowing. Means there was a regular pattern before, but now this pattern is completely dispersed. So it means there is no current. So no current indicates that there is a smoke that is available into the chamber. So our detectors operate accordingly. Okay, so this is the process how the ionization detectors they work out. In the photoelectric and the ionization detectors, the false alarm ratio is very high. Because when we are saying smoke has shiny particulates, it is not on the only case. Okay, it's not only smoke, okay, but shiny particulates are also associated with dust particles. right? And shiny particulates is also associated with any type of aerosol signatures. Okay, so any type of sprays, perfumes, okay, mist or water, any aerosol signatures, okay, the detector will operate. Any aerosol, spray, perfume, anything. So you'll see that most of the time we have a smoke tester spray. So spray is actually giving a mist type of a aerosol signature within the chamber. So aerosol is also small moisture mist droplets are also shiny in nature. So they also reflect the light. So yeah, any aerosol signature will trigger the alarm. That is why the false alarm ratio in the photoelectric principle is also high. Similarly, if I'm going to discuss about the ionization detectors, the major barrier, if through understanding throughout the whole process, the only way I can trigger an alarm is the discontinuity of the electric current, right? So this electric current can be discontinued with various other reasons other than only the smoke itself. Like for example, if your charge plate becomes rusted, any type of rusting comes, okay, so of course it has lost its integrity. Negative particles will not attract towards the positive, and the electrical will discontinue. So your alarm will trigger. Similarly, if there is any type of moisture accumulation, droplets, okay, that will also give discontinuity in the electric current. Okay, so any accumulation of anything with the charge plate. Then if your radioactive element is not giving charged ions, or in other words, if I can say there is any problem with your batteries, power source, okay, if there is any problem with the power source, the radioactive element will not give ions. Ions are not generated, no electric current, right? Yes, so that can also result in false alarm. So there are various reasons. The false alarm ratio is very high in smoke detectors, specifically in video based and your ionization detectors. We are not using ionization detectors anymore, right? It's being banned by the two very important organizations. Okay, the first one is the Clean Air Act, and the Environmental Protection Agency, EPA. So CAA and EPA. So they both have banned the use of ionization detectors anymore further. Why it's not being used? First of all, uh-huh. Okay. Mm. Radioactive element. Okay, the radioactive element is actually an alpha emitter. Alpha emitter is actually not that much dangerous for the human skin, for human interaction. It is not dangerous. Okay, but what happens here is that it is a free energy source that is available, can be utilized for various other activities. Okay, so that is why they are not allowed. The second thing, the most important parameter for the ionization detector is the dumping. Okay, so what we are trying to do is that we usually, whenever we are going to remove ionization detector, okay, it has a radioactive element. So what we tend to do, we just, most of the companies, when they are said, okay, you have to remove them, they are removing it, they close them in cartons and they keep it there somewhere in the store. So it means free energy source available in the store somewhere in the cartons. The agencies here, okay, what they want, they don't want that. Any radioactive material, okay, according to various international standards, any radioactive material needs to be disposed of appropriately. Okay, and the appropriate disposure is that if, for example, I'm using a Siemens ionization detector, if I'm no longer using it, I should pack it and send it back to the Siemens rather than storing it at my own facility. And Siemens, who are actually producing this, they are the only one who have an appropriate disposal procedure for the radioactive element. Other than that, they cannot produce any type of ionization detectors. Okay, so that is why the disposal is also one of the most challenging factor. Okay. So these are the two types of detectors, photoelectric and ionization. Let's discuss about the third type of a detector, that is video-based detector in the smoke detection. So why do we require video-based detectors? Let's see that. So in warehouses, okay, usually, let's say if I have a warehouse where the ceiling height is far more greater, let's say 15 meters, okay, and I have combustibles that are available with me, limited amount of combustibles, okay, and then I have other combustibles available, very high rated, highly combustible materials available, but that is far away, okay. Now if I need any type of a protection here, okay, I know that the capability of the material at the initial stage is going to give me smoke. Let's say it's a wood material, okay, class A combustible, it's going to give me smoke at a very initial stage. So if I want to have a smoke detector, okay, but the ceiling height is very high, so here the only option that I have is a beam detector. Now the beam detector that I'm going to store here is, the requirement is 10 meter and above, right? So now what happens? Let's say the fire starts at a very initial stage. Flame starts. What will happen? Smoke will be generated. But to reach a height of 10 meter, okay, the smoke is not enough. So what will happen? We have, of course, unintentionally, we don't know, but flame will become more and more bigger. Okay, more and more and more bigger, and eventually it will reach to a point where it will reach the beam detector. Now the beam detector gets operated. Detector operates, security comes inside. At this stage, the fire has already reached to a growing state where he cannot interact with it. Okay. Now the only thing he can do is just he can just call the help or to the authorities or anywhere. So what will happen? Flame has already grown to a growing stage. From there, it has gone to a nearby combustibles, and eventually from one warehouse to second warehouse to third warehouse, and it propagates like that. Now there is a delay. Where is the delay? The delay is that once the flame was at a very initial stage, I should have detected it there. If I would have detected it there, security comes, he could have used extinguisher to completely control the flame. That was the point where he can interact with the flame very easily. Okay. So now unintentional delay is there because I don't have any other option here for the detection. Now this phenomena is known as stratification. Meaning in NFPA 72, you will see that whenever you will read NFPA 72, it will always say that the detector should be placed in an appropriate location to avoid stratification. And what does it mean by to avoid stratification? It means that you have to avoid delay. Okay, so the detector should be placed for timely operation to avoid stratification. What is stratification? This delay is the stratification phenomena. Okay, for that purpose, what we want a type of a detection that can actually give me alarm at a very initial stage. For that purpose, I use a video based detection. But remember, the video based detection is expensive. Okay, so not all warehouses we can protect by the video based. It requires large maintenance also. Okay, now what happens in the video based detection? It has a conical view of the whole area, not the whole area, but a conical view of the surveillance of the area that it can cover up where my combustibles are available. Okay, now how this cameras are installed or video based detectors are installed are the same way as we do the CCTV. Okay, we do the surveillance vulnerability analysis, SVA. We perform the SVA and we tend to identify at which point which conical vision should be uh, under the direct access of our cameras. Anyways, this is our materials. Now the video-based detector installed. What the video-based detector will do? As soon as a smoke structure will appear on the top of the material, what it will do? It will start taking photos and deliver it to the computer. It will start taking photos and deliver it to the computer. The computer has a software which has various different structures of smoke installed, stored orderly inside. Okay, it has various different structures of smoke that has been stored inside. It will take photo from here. It will compare it with the storage photos. If this comparison is 70%, okay, it will initiate an alarm. Okay, so like this, at the very initial stage, I can get a detection from the hazard. Now, these type of detectors I cannot install in daylight. During normal working areas, I cannot install. Usually the warehouse fires are usually at night whenever the warehouse is being locked up, right? They're usually the incident hackers. In daytime, usually people are walking around, so you don't require them to be operated at daytime. In daytime, if you operate also, there are so many false alarms that can be initiated. Like for example, someone is removing dust structure is formed, it will take photo and it will start triggering the alarm. So in daytimes, they are usually completely switched off. At night time, they get usually activated. Now the lens requires maintenance. Okay. Why? If any accumulation of water, any accumulation of dust, any accumulation, any foreign material on the lens, it will affect the detection capability of the detectors. Second thing is that it requires more maintenance on the software also of the computer. Okay, that needs to be completely checked. Health check of the system should always be there. So it requires more maintenance in a twice in a couple of months gap. Okay, after every 2 months it should be checked. Yeah, the lens and then the computer software, everything should be checked so that a detector is showing its capability accordingly. But again, there is a false alarm ratio that could be available, and that could be because of dust. Any type of forklift operating can create a smoke structure. Any type of machinery equipment that is running can create a smoke structure, and it can start taking photos and initiate an alarm. Okay, so that is the purpose of the video-based detectors. That is how it tends to work out. Usually we use it so that we can avoid stratification and we can provide an timely uh, detection, timely response. Okay. So in the examination, they can ask you the type of a detectors used in warehouse occupancies or any type of storage occupancies, commodity storages. Okay, they can use any type of terminology. Okay, to avoid stratification. Then they can provide you options. So video-based detectors are used in these occupancies to avoid stratification, because in these occupancies the ceiling height is very high. Okay, so any type, actually all the detectors should be installed to avoid stratification, but in warehouses, ceiling-based detectors will always have stratification. Beam detectors will always have stratification. So for that purpose, these detectors are installed so that we can avoid stratification in warehouses and commodity storage areas. Yeah. That is for the smoke detectors. Sorry. Let's move on towards the heat detectors. Before mentioning about the heat detectors, okay, we need to understand the phenomena of the heat detector, how the heat detectors tend to work out. So for that purpose, the first important thing about the heat detector is that we need to see at how the base of detection is started in the heat detectors. Heat detectors, they came into production in 1860s with the sprinkler systems. With the sprinkler systems, okay? And with the sprinklers, better development of sprinklers. Why? Because they both are convective devices, okay? They both are convective devices and they both have the capability to operate based on the convection heat transfer mechanism. Okay. So heat detectors, they came with the sprinklers in 1860s. Heat detectors, same like sprinklers, they also work on various different principles. Okay, the all type of principle. The first type of a principle was fusible element type. In this fusible element type, okay, we usually had two diaphragms. One diaphragm that is being pressed by the spring, okay, and then there is a link attached to it, okay, and we had a base. So now what will happen, okay, that the spring is actually being pressed down, okay, by the diaphragm. As soon as the link breaks, the spring is expanded up, okay. So heat rises, link breaks, okay, the thing that is actually pressing the spring, it releases up. So when it releases up, the diaphragm moves up, connects it, and initiates an alarm. Okay, so this is the link was there, and this link is usually made of. We have discussed in the basics of ion science. It's made of eutectic metals. Eutectic metals: bismuth, tin, lead, and cadmium. Okay, so that is the fusible element type. Now here, all the heat collection point is a single point. That is the link itself. Okay, that is a single point. Then we have the second type, that is the continuous line type. In the continuous line type, okay, we have two metal strips, okay, that have been kept apart. And at the bottom, they are somewhere connected to each other. So what happens? Now these two metal strips, they have been kept apart by the strings itself. Okay. So now what happens when the heat rises? Let's say from one portion, one strip breaks down. One strip breaks down, it releases the copper. The copper comes into a final position in the center somewhere here. Okay. Alarm will not trigger. Why? Because there is still an open contact. Heat from here needs to be also increased. So here the heat increases, breaks down, and this copper also moves towards a center point, making a close contact, right? Joining both together. And then the alarm triggers. So this is a double entry point. A clear difference. This is a single entry point, single point where the visible element was working. Now this is a double point, okay, from left side and right side. Both sides, if the heat is, the temperature has reached the threshold limit, then only the detector is going to operate. That is the continuous line type of the heat detector. The problem with these detectors is that once they operate, the whole chamber need to be replaced. Okay, that's why these detectors were quite costly. Okay, and any false activation will also require us to change the whole chamber. Then we have the third type of a detector. That is bimetallic type. Bimetallic type. Okay, in the bimetallic type, we had two metal strips. Okay, again, one with high expansion. We have discussed this again in basics of ion science, and low expansion. Right. So what happens when the heat rises? Same temperature. At same temperature, what will happen? Both the metal strips will expand. So high expansion one will expand far more quickly. Low expansion one will less expansion. Eventually, they will close at to a point, creating an alarm, creating a normally closed point. Okay, so this is the bimetallic expansion. Now, in the bimetallic expansion, the high expansion metal strip is eutectic metals. Again, the low expansion metal, okay, the low expansion metal is actually INVAR. And INVAR is a combination of nickel and iron. Nickel 36% and iron 64%. Okay. So that is bimetallic type of heat detectors. So these are the all type of heat detectors that were used by us to measure the intensity, to measure the heat rise in various occupancies. But again, once this detector operates, okay, then the whole chamber has to be replaced. Okay. So moving on, heat detectors can be categorized into three types as we have discussed. Okay. The fixed temperature heat detector. Nowadays, we have electronic spot type detectors that have thermistors. Okay. So they have temperature dependent resistors, thermistors. Temperature is higher, resistance becomes lower. Okay. Variable resistance. Okay. Temperature becomes higher, resistance becomes lower, allows the current to flow, and eventually closing the circuit. Okay. So fixed temperature heat detectors, they operate up to a fixed temperature rating. It could be 57, 55, 53, depending upon the requirement of the occupancy. Then we have rate of rise heat detectors. These type of heat detectors, they operate whenever there's a temperature rise of 7 to 8 degrees Celsius per minute. They will operate. In other words, I can also say that the fixed temperature heat detectors, okay, they will respond to a slow developing fire. And rate of rise usually responds to fast developing fires. And that is why sometimes we have a combination detector. A combination detector of fixed temperature and rate of rise, combination detector. Yeah. So in examination, they can ask you about the fixed temperature and the rate of rise. Okay, so fixed temperatures for slow developing fires, rate rise for fast developing fires, and in between we can have a combination detector. We usually have for fixed temperature and rate of rise as a combination detector. Okay, so this, so that we can have a fixed temperature and rate of rise both available in one detector, so that it can detect slow developing and fast developing fire at the same time. Yeah. The third type of a detector is a rate of compensation detector. Why do I require a rate of compensation? For that purpose, we need to understand one phenomena. So, heat detectors, we have discussed three types. First is fixed temperature and rate of rise. Now we will discuss about the phenomena of the third type of a detector, that is rate of compensation detectors. So let's say I have a flat smooth ceiling, okay, and a flame that has appeared somewhere. Now the flame releases heat directly on the ceiling. What will happen after reaching towards the ceiling? The heat temperature always travels from higher to lower temperature, right? Heat will transfer from higher to lower temperature. So heat will transfer directly towards the farther end. This center point from the tip of the flame to the ceiling, this center point is known as center line. And this corner point of the ceiling is known as ceiling jet. In other words, one of the terminology that we can say is that the temperature at the center line will be always greater than the temperature at the ceiling jet, right? The temperature at the center line will always be greater than the temperature at the ceiling jet, right? Okay, 2-3 phenomena that we can understand from here. Now, what happens here is that what is the heat movement that occurs during the flame appearance? We need to understand that. Now the center line, first of all, when the temperature will rise up to the center point, what will happen? There is an area of effectiveness. This area of effectiveness means that at one block where the temperature is right, up to one point, the heat will distribute effectively. Okay. From one block, the heat will distribute effectively up to 2 blocks. Okay. Up to a specific area. And then there will be a gradual decrease. Okay. So if I want to draw a graph between the distance and the temperature, okay, so I can simply say that the temperature will remain consistent up to a point, okay, then there will be a gradual decrease, and then if the source is continuously available, then there is a chance that the source will again, the temperature will rise, okay. So this consistency is up to 0 to 2 meters of the distance, okay. Third to fourth meter, what it happens is that it tends to effectively distribute it. Okay. Now this is the area of effectiveness. Okay. The area of effectiveness for the heat detector to provide up to 2 meter. But we are ignoring one thing. The center line is not as much narrow as I'm making it here. Okay. When the heat will rise, it will have a specific width. Right? It will have a specific width, right? So this width is usually 1.5 meter. Okay. And then the area of effectiveness is up to 2 meters. So all in all, 3.5 meter, we can say 3.5 meter is the area up to which the heat can be distributed. We can say consecutively, not consecutively, but approximately up to a point where the difference will not be that much. Okay. NFP 72 says, how much should be the distance between heat detectors? Yes. Huh? 9 meters smoke detectors. Heat detectors. GA life safety. NFP 72 says that the heat detector distance is based on the manufacturer's instruction. It does not specify any distances. It says it's based on the manufacturer instruction. UA life safety code says that whenever you're going to use a heat detector, it should be 7 meter apart. Okay. So usually some countries, where some manufacturers, they make it 5 meter apart. Okay. 7 meter apart, it means that the area of detection will be how much? Area of detection will be 49 square meter, right? If I want to break this one out, okay, I can also simply say that one detector's area of effectiveness or area of detection is for one detector is 3.5 meter, right? And similarly, 3.5 meter. That is why it is 7 meter, right? So I cannot predict where my center line will be. Flame can appear anywhere in the room. But what I want is that after every specific distance within the 3.5 meter, my detector should be available. So that is why the distance of the heat detectors are specified by the manufacturer. Okay, it is always specified by the manufacturer. Okay, because the total area of effectiveness is 3.5 meter. Similarly, if we go refer towards the sprinkler systems, NFP 13, residential buildings, what it indicates. Okay, branch to branch, the distance should be 3 meter. approximately, and within the branch 4 meter. Area of protection, let's say approximately 12 square meter. It's 3.86 and 2.8 something, but let's say 3 and 4. Okay, just to make it easy. So sprinkler 1.5 meter, 1.5 meter area of effectiveness. 2 meters, 2 meters. I cannot predict the center line, but I know at 1.5 meter my sprinkler should be there. 2 meter my sprinkler should be there. Okay, so basically that all depends upon the center line width, the center line effectiveness. So I cannot predict where the center line will be. It could be anywhere, but within that distance, my convective device should be there, either heat detector or sprinkler. Okay, based on the requirements, it should be there. Okay, that's why I have a specific distances in the convective devices. Now, where does the rate of compensation detector comes? Now, rate of compensation detector comes whenever I replace this heat or flame with any type of an electric heater, cooking appliance, anything. When I replace the flame with heater, heater will also perform the same action as the flame, central line. Heat will rise up, it will reach up to the ceiling, and then heat will distribute. Now, what happens is that when a heater releases heat, if I have a fixed temperature heat detector, heat will collect at one point in the fixed temperature heat detector, right? The heater is programmed to provide me a temperature of 32 degrees Celsius. But once, if a fixed temperature detector is there, it will collect heat. If the outside temperature is 32, the collection point of temperature will be far more greater. It may be 65 degrees Celsius because it's concentrating and collecting heat at one point, right? Continuously. So at that collection point, there is 60 degrees Celsius. So there is a temperature differential, meaning the surrounding temperature and the temperature at the heat detector, there is a vast difference. This feature is known as thermal lag feature. In fixed temperature and rate of rise heat detectors, they have one collection point. And at that collection point, if the temperature reaches 60 degrees Celsius, even though I will enter the heat detector is operating, but when I will enter, I will find it 30 degrees Celsius. Why my heat detector is operating? Right? It means my heat detector is faulty. No, heat detectors are the most reliable detectors with the lowest false alarm rates. Okay, so the only that feature is thermal lag feature because the heat is being collected at one point, and that point the temperature is increasing continuously. Okay, so fixed temperature and rate of rise heat detectors, they have high fixed temperature and rate of rise heat detectors, they have very high thermal lag feature, meaning as soon as there's a temperature differential, these detectors will get operated. To avoid this problem, to use detectors in those areas where already I have heaters or commercial cooking appliances, like in hotels, restaurants, okay, when they have heat detectors nearby, they trigger it. So they don't have any option. So they are thinking maybe the heat detectors are faulty, but actually heat is escaping and really reaching to a fixed temperature threshold point. So to avoid that problem, what we want a type of a detector that does not detect heat only from one point. I want that detector to detect heat throughout the whole 360 radial. Once the radial temperature is 57 degrees Celsius, then only it should operate. Okay. So once the radial temperature is 360 degrees Celsius, 360 radial is 57 degrees Celsius, then only this detector should operate. This type of a detector is known as rate of compensation detector. In other words, if I want to say in a thermistor point of view, thermoelectric effect, okay. Thermoelectric effect, if I want to say thermistor way, okay, I will say I have multiple thermistors available. Okay, this resistance will become lower, current will flow. It will block here unless this resistance does not become lower. So similarly, all the resistance needs to become lower. Then only the current will flow and eventually my detector will trigger. So they have, yes, rate of compensation detectors. They have very late response time. but they are very effective in those areas wherever I have heating appliances available. Okay, where my fixed temperature and rate of rise is going to trigger a false alarm, their rate of compensation is a more reliable detector for me. Now, talking about the rate of compensation detectors, they are considered to have they are the detectors that have the low thermal lag feature. Means thermal lag can, of course, never be completely removed. The temperature difference can never be completely removed because there is a collection point. These thermistors, they are a collection point, right? So thermal lag feature can never be neglected or avoided or removed. There will be always a thermal lag feature, but low thermal lag. So low thermal lag is always in rate of compensation detectors. That is the third type of heat detector. In the examination, they may ask you a question that the type of a detector that corresponds towards low thermal lag. Okay, so that will be rate of compensation detectors, because these detectors, they detect the temperature of the whole ceiling to be radially to be 57 degrees Celsius before it will operate. Okay, so these are the rate of compensation detectors. Okay, moving on, let's discuss about the radiant detectors. So we have radiant detectors. Radiant detectors can be categorized into two types. We have discussed already: ultraviolet and infrared. Ultraviolet has a wavelength radiation 0.10 to 0.35 micrometer. Infrared radiation 0.76 to 220 micrometers. Right? Ultraviolet, they have high expansion. Infrared, they have low expansion. Okay, that's why they can travel less distance and they can travel more distance. Infrared is also known as to be a contact point detection, while the ultraviolet, they are famously known for wide area detection. Yeah. Ultraviolet and infrared detectors, they can be combined together as a combination detector, and these combination detectors are known as multi-band detectors, means multiple bandwidth. So multi-band detectors can be a combination detector of ultraviolet, infrared, and infrared, infrared. Okay, because infrared radiations bandwidth is far more greater, so I can have two multiple bandwidths in one detector, or I can have ultraviolet and infrared radiation in one detector. So these are the multi-bandwidth detectors that I can have for one facility. So ultraviolet and infrared detectors, okay, they have too much false alarms. Again, the false alarm ratio can be because of the lenses that is available on the ultraviolet detectors. Whenever there's a lens, any type of water accumulation, dust, okay, any type of surveillance, obstruction, okay. So these detectors, their capability will be, their detection accuracy will be reduced. Then sunlight, welding, any flashing of lights, okay, lightning, hot objects, hydrocarbons, a lot of reasons that can actually trigger the ultraviolet and infrared detectors. Okay, infrared detectors, usually any hot object, it gives off infrared radiation. So infrared detectors can be also triggered because of the false alarm. So they also have a good high false alarm ratio. We are going to discuss the radiant detectors because they are very quickly we can detect. Even a spark, a lighter spark can be detected by the infrared radiation. That is why the infrared detectors are also known as spark detectors. Okay, and we will see that in ultra high speed water spray systems, we'll see how the detectors they tend to respond to it. How detectors, how a single spark will operate the ultra high speed water spray system very effectively within 100 milliseconds. Yes, so this is for the radiant detectors. Then we have gas detectors. Gas detectors, they work on three principles. The first one is the semiconductor principle. Semiconductor principle, we have semiconductors available with us, a barrier. In semiconductors, we have P junction and N junction. N junction means more negative ions, less positive ions. Similarly, a P junction means more positive ions and less negative ions. So what will happen? Whenever a gas enters, same like smoke, it has the capability of deionization. So whenever a gas will enter, a deionization process will start. What will happen? Deionization means that the junctions will lose their ions. So N has more negative ions, so it will lose more negative ions. Similarly, P has more positive ions, so it will lose more positive ions into the normal barrier. So losing of negative ions means flowing negative ions. A flow of negative ions is electric current, right? So from here we can detect that the gas is available in the atmosphere. When a gas enters, okay, the current, there's a current deviation, okay. A current deviation explains that how much, I mean, small current variation explains that there's a gas that is available in the atmosphere. Higher the current variation, okay, means more concentrated gas, okay. The gas is in more concentration. But the problem with the semiconductor principle is that we can not tell what type of a gas it is. It will explain us based on the ampere meter. Okay, it will explain us the deviation. With the deviation, it will explain us that there is a gas available, but it does not explain what type of gas, whether the gas is toxic, it's flammable, or what type of gas it is. But there is a gas available. That's it. That's what we will know from the variation. The more the variation means the more concentrated gas it is. Okay. The less variation means less concentrated gas available. It only explains that there's a gas available in the atmosphere. What type of gas? Further clarification is not available. Then we have the second type of a principle for the gas detector, that is catalytic element principle. In the catalytic element principle, okay, catalysis means a type of a component that boosts up the chemical reaction, but by itself it remains unchanged, right? So what we do here is that we have usually a spark generator, same like a lighter. We have a spark generator that is available, and this spark generator is basically inside a big chamber. Now this chamber, it has small orifices available, and these orifices will only allow the gas to enter into the chamber. Once there is actually a button that is available at the bottom. Usually we used to press the button and spark will be generated. Okay, but nowadays automatic is also there. But as soon as the button is pressed, spark, before the generation of the spark, all these orifices will close. Okay, so now what happens if any flammable gas enters into the chamber? Okay, so I press the spark button, orifice closes, spark is generated. What will happen to the spark if a flammable gas is there? It will convert into a big flame, and it will convert into a big flame, and then it will disappear because limited amount of gas only entered, right? So this temperature rise can be monitored by a thermography screen that is available at the outside of the detector. The thermography screen will give me the temperature, what temperature rise was inside the chamber. So it will provide me an information that a flammable gas was available in the atmosphere. Okay, that is the catalytic element principle used to detect flammable gases in the atmosphere. Then we have the third type of a gas principle, that is the infrared absorption principle. And that we have discussed. Infrared absorption principle we have already discussed, okay, that it passes freely through diatomic and gets absorbed in monatomic. Gets absorbed in monatomic. So it will pass freely through any type of oxygen, nitrogen, dry air, it will pass freely, but it will get absorbed whenever there is any type of an hydrocarbon that will come. Okay. So these are the three important gas principles: infrared, semiconductor, catalytic, and infrared absorption principle. So these are for the gas detectors. Some basic rules for the detector placement, some basic code from the NFPA 72. Let's see. Okay, the detector, whenever it should be placed, okay, it should not be placed, it should be placed not less than 4 inch from the ceiling. Not less than 4 inch means that this distance should be 4 inch from the detector. Okay, then if you have a combination detector of smoke and heat, okay, smoke and heat combination detector, the distance between heat detector smoke detector combination to heat detector smoke detector combination should be 50 feet, approximately 15 meters. Usually the common distance between smoke detectors, okay, is 9 meters apart. Whenever a, a heat detector is installed with sprinkler, and the distance is within 0.6 meter. Okay, so the heat detector should be much more sensitive than the sprinklers. Why? Prior to the operation of the sprinklers, we should know what is happening. Okay, so that we can, if it can be avoided, we can avoid the operation of the sprinklers. So these are some of the requirements of the detector that needs to be placed as per the NFPA 72. Okay. Then let's move on towards the notification appliances. Okay. Residential is light hazard and the sprinkler coverage area is around 21 square meter. Uh, Residential is light hazard occupancies and the sprinkler coverage depends upon the K factor. Okay, so in the light hazard occupancy, there are multiple K factor sprinklers, 5.6 or 8.0. Okay, so if you're using a 5.6, okay, like you're saying in elevators, okay, elevator shaft phase or hoist phase, okay, so we can say that, I mean, the minimum area of protection should be 12 square meter. Okay. And yes, based on the openness, because there are two important considerations that we have to make whenever we are going to install the sprinklers. Okay. First of all, the type of sprinkler installation that we go for is the actual delivered density, ADD. Okay. In that, we have to make sure that the distance is specified in such a way that any type of air movement or any type of obstruction is not disturbing the umbrella pattern. The minimum area of protection that we should always cover that operates as per the NFP 13 requirements of 7 psi minimum operating pressure from one flowing sprinkler should be 12 square meter. Yes, if you have space requirements and there's no space restrictions, no obstructions, yes, then it can go up to 21 square meter. Okay. Uh, Elevator pits actually heat detectors. Okay. And elevator pits for heat detector and sprinklers. Okay. But I would the sensitivity is actually it should be same actually. The heat detectors and sprinklers they should have same sensitivity in this in the elevator pits. Okay, heat detector should be more sensitive in an area where the distance is less. Why? Because prior to the activation of the sprinkler, we need to know what is the issue actually. But in the pits, they are usually more like confined spaces. Okay, now that also changes with the requirements depending upon the temperature requirement which is available. Okay, now I mean there are some like structural structural you can say limitations to the detectors and sprinklers. Like for example, if I have a concrete has the if there's moisture accumulation there, then moisture actually destroys the concrete. Okay, and moisture destroys the concrete and moisture at the same time, okay, is a weakness for the concrete can then cannot sustain that much amount of heat. If the concrete is in a dry area, then it can sustain much more amount of heat. If it can sustain more heat means that the surrounding temperature can also be increased. So based on the structural element, we have to be very careful when we are installing heat detectors and sprinklers. uh, Here I can say confidently in occupancies that if a 0.6 meter tender sprinkler, then anywhere the heat detector should have more sensitive, should be more sensitive than the uh, sprinklers. But in pits, in any other confined spaces, okay, the scenario is a little bit changed based on the structural construction. Okay, then we have to analyze what are the structural elements that are being used. Okay, so based on that, we can say that the heat detector should be exactly the same, or it should be more sensitive. Okay, because we don't want a continuous triggering of the heat detector, false alarm, right? And pairs and confined spaces, these are areas which are not easily or readily accessible. Okay, so for that purpose, there are some limitations that are depending upon the structural elements. Okay. I just give you an example of like a concrete. Okay, because if moisture accumulation is there, then the concrete cannot sustain heat for long. But if it's not there, dry areas, then the heat, the temperature increment is much more quicker in those areas. So for that purpose, we have to be very careful with while we are selecting the sensitivity in confined spaces. Notification appliances. Okay, so in the notification appliances, usually what we have a sounder. Okay, and the sounder's purpose is to send sound towards the receiver, and a receiver could be any type of a person who is actually receiving the sound, right? It could be any ear that is receiving the sound. So whenever the sound is traveling, it is traveling as an air as medium, right? It is traveling air as a medium. So it means that there will be losses, right? So whenever it travels through an air, there are losses. So with each travel of sound, okay, now based on the obstructions, there is a noise to loss ratio. Okay, what NFPA 101 indicates, and NFPA 172 also, okay, that a noise, a sounder or an alarm bell, okay, should have a noise level of 75 dBA. Okay, 75 dBA for the occupants. What is the A? The noise level. Okay, if I want to avoid the noise level, if I want to say that the units of the noise level is decibels, what is A? Why we add A? Any ideas? Usually, whenever you open the NFPA 72, the noise level is decibels, dB, right? So why do we add A there? In smoke detectors, notification appliances, right? It is a weighted signal, exactly. It is a weighted signal. A is a weighted signal. Weighted signal means A is weighted for the human ear sensitivity. Means when a device is being rated as 75 dBA, means that the noise ratio that is being calculated or calibrated is kept in consideration, that it is human ear sensitivity is kept in consideration. Similarly, like we have dBp. Now dBb, B weighting scale means that the noise level starts from a very lower level, and then it reaches to a very high peak. Okay, slowly and gradually, instantaneously with time. Like for example, if you're standing near towards a jet plane, at the starting you will not hear any sound, but once the engine starts running, from slowly to a very high peak level where your human ears cannot bear it. Okay, so that is a B scaling. Then we have the C scale also, C weighting scale. C weighting scale is a scale of impact, sudden explosion, sudden noise, sudden large noise that can damage the hearing of human ears. So that is DBC, impact noise, explosion noise. Okay, so that is why A means that it is the noise level that is kept in consideration with the human ear sensitivity. 75 dBA. Okay, should be the noise level for the occupants to provide any type of a notification. Whenever a noise is being traveled through air as a medium, okay, there is an obstructions. These obstructions through air as a medium can be defined into two types. Either it could be barriers or it could be absorbers. Okay, like for example, in a room, okay, the furniture is an absorber. Carpet is an absorber. Okay, any type of wall coatings, okay, they all are absorbers, means the noise is absorbed, the intensity of the noise will be less. Similarly, if I want to give you an example, let's say that if I have a room without any furniture and I'm going to make a sound, it will have an echo, right? It will, the intensity will increase, it will be much more higher. But if I have a room completely filled with furniture and I try to make a similar sound, what will happen? The intensity will be much more lower. Why? Because there are absorbers available. Okay, barriers means clear obstructions between the source and the receiver. Okay, it could be doors, walls. So whenever a door or wall comes in between the air, the noise, okay, usually we say a 15 dBA loss is there. Door to noise ratio loss, okay, door to loss ratio of noise is 15 dBA whenever it passes from door or wall. Okay, for example, if I have a sounder in this room, I have a door and I have a person outside, 75 dBA is the sound that my sounder is making. So when it passes through a door, so I can expect 60 dBA to reach towards the person. 15 dBA will be the loss ratio from door to wall. Okay, so that 15 dBA loss ratio is always added up. So and then if I want to make sure that at the corner and I want 75 dBA, so how much ratio I have to keep it here? If I have one wall, I have to keep it 90 dBA, right? Then door to wall ratio 15 dBA loss will be there, and then on the other end 75 dBA will be there, a person will reach, right? So if I want here to reach 75 dBA on the other side of the wall, I have to keep it here 90 dBA. Okay, because 15 dBA will be a noise loss ratio. Okay, so like this, there are obstructions can be categorized into two types. Either it could be a barriers in the form of doors and walls, or either it could be in the form of absorbers. Okay, like furnitures, any type of carpetings that are available inside, that can be considered as an absorber. This reduces the noise loss ratio. Okay. Okay, notification appliances are categorized into two types. One is the public operating mode, and the second one is the private operating mode. What is the public operating mode? Public operating mode, in which I want a notification to be given throughout the whole occupancy. Okay, my all buildings, usually wide area notification. Public operating mode, Ibrahim, public operating. Private is for, yes, healthcare. Okay, sorry, I thought maybe you're saying healthcare. Yes, private is for healthcare. Public operating mode, yes, is for wide area notification, means the whole occupancy I have to provide a notification. Exactly. Private operating mode, where I don't want the occupancy to get the notification, where I want to give the notification at specific stations. Okay, like healthcare. I don't want notification to be given to a patient who is already in ICU. I just want a notification to nursing stations. Like in prisons, I don't want all the prisoners to know that there is any type of an emergency. Okay, so that they will start making developing other plans. So I just at specific stations, monitoring stations, I will just give a notification. That is the private operating mode, right? So I have public operating mode and I have a private operating mode. NFP 72 has two very important requirements for the public operating and private operating mode. But before that, we will just discuss what is the sound pressure level. Okay, whenever we have to calculate any occupancy notable notification device, we need to know the sound pressure level. What is the sound pressure level? Sound pressure level is equal to the notification plans. Notification plan sound level, that is dBA, plus the ambient sound, that is also in dBA. Okay. So notification plan sound plus any type of an ambient sound. Ambient sound means any type of sound that is available in the surroundings. Okay. All added together gives me the sound pressure level. Okay. The sound pressure level of any notification appliance in any case as restricted by OSHA and NFPA should never be 130 dBA or above. It should never be 130 dBA or above. Why? Because at this 130 dBA, okay, or above, it can cause permanent human hearing damage. Permanent damage to human hearing. Permanent damage to human hearing. Okay, it should not, never in any case should be 130 dBA. Okay, the sound pressure level can be 100 dBA. The sound pressure level can be 100 dBA, but 100 dBA is usually for people who are like you can say sleeping occupants, okay, or so people who are on sleeping pills or hearing impairment, okay, there they can have 100 dBA. Sleeping pills or hearing impairment means hearing issues. So there the noise level can be 100 dBA. Okay, but whenever the noise level will be 100 dB or above, okay, there I need a visual notification also. A type of a flasher. Okay, I'll be using it there. Okay. Like for example, in libraries, okay, where people are usually have earphones, okay, and they are hearing towards the loud music, okay. So even if the notification appliances are running, they are not aware of it, right? So for that purpose, a flasher should always be there. So certain occupancies require flashes to be there with the notification appliances. NFPA says a general requirement that if you have 100 dB and above notification plans, it means that there are people are either on sleeping pills, hearing impairments, or noise is blockage. So there is a possibility at 100 dBA also they may not listen. So there a flasher should always be there. Okay. So that is the sound pressure level. First important thing about whenever we are going to discuss about the NFPA codes, okay, about the notification appliances, the sound pressure level will be there. Notification appliance sound plus the ambient sound. Ambient sound means any type of surrounding sound. Okay, if this surrounding sound is available for like 60 seconds, if any sound is available, to take that sound level, okay, and add it towards the notification appliance and calculate what will be your sound pressure level of the notification appliances. So either you can do this or you can add 15 dBA. Okay, both are the conditions that are applied by the NFPA 72. We'll discuss it now. Okay. But in any case, the sound level should be always kept in considerations. Okay, so the public operating mode and the private operating mode. Okay, let's see what are the requirements. In the public operating mode, with the first requirement that NFP 72 say, first of all, we'll discuss about the public operating mode, that notification plans we know already. Okay, it should be 75 dBA, right? But the requirement comes with the ambient sound. It says that if there's an ambient sound level, you have two options. Either if you know from the audiometer that if the sound level is 5 dB or 7 dB, add that one, okay, from the sound meter. but that sound should be lasting for 60 seconds. Okay. For example, any drilling is going on. Okay. It should last for minimum 1 minute. Okay. If it lasts for 1 minute, I will add it. If not lasting for 1 minute, I will not add it. Okay. So 60 seconds, either from the sound medium, or I will just simply add 15 dBA. Okay. I will calculate both, whichever has the greater value, I will use it. Out of these two, whichever has the greater value, I will use it. Okay. So let's say from the sound meter, okay, a generator is running from the sound meter, it's showing me, okay, 13 dBA. Sound is there to a point where I am standing. Okay. So I add 13 dBA here. It gives me 75 plus 13. Okay. It gives me 88, right? And I will take the second requirement also. Okay. Add 15 dBA. It gives me 90 dBA. So which one I will select? Whichever is greater, that is 90 dBA. Okay. Similar requirements for private operating mode, but in the private operating mode, same again, you have measurement from the sound meter. Okay. Or you will add 10 dBA. Here it was 15 dBA. In the private operating mode, I will add 10 dBA. Okay. There I will calculate whichever is greater, I will add it there. And that will be the sound pressure level of my notification appliances. Okay. So sound pressure level is very important for my notification appliances. So sometimes when we are saying that my notification appliances set at 75 dBA, it doesn't mean that it is designed for 75 dB. It means that the sound pressure level that has been calculated by the fire protection specialist, he calculated it up to a point where he think that the sound pressure level should be 90 dBA, so that at the farthest point where the coverage is maximum, there it should be 75 dBA. So he has already kept in consideration the obstructions that are available. Okay, so that's why whenever notification appliances are calculated, they are always calculated based on the sound pressure level. Why? Because the sound will travel through air as a medium, and there will be obstructions as well as there will be absorbers. That will always decrease the sound level whenever it will travel. So based on that, we usually say the NFPA1 says that, okay, you know about a public operating mode and private operating mode. So what is the evacuation signal that any audible notification appliance should be providing? So the evacuation signal is always a temporal 3 pattern. What is a temporal 3 pattern? 3 cycles of on and off, and then silence, and then 3 cycles of on and off. This is the evacuation signal. Okay. So if I want to convert it into tones, it will be something like 2, 2, 2, 2, 2, 2. It will be something like that. Okay. So 3 cycles of on and off, then silence, then 3 seconds of on and off. And this silence can be up to maximum of 180 seconds. That is the evacuation signal for the temporal 3 pattern, the evacuation signal as directed by NFPA1 for the audible notification appliances. Similarly, we have one more pattern, temporal 4 pattern. Temporal 4 pattern is for carbon monoxide signals. We have 4 cycles of on and off, and then off, then 4 cycles of on and off similarly. Okay, so this is known as temporal 4 pattern. And temporal 4 pattern is for carbon monoxide signals. If evacuation signal is temporal 3 pattern and there should be a silence, why we don't have this type of signal in our residential buildings? In residential buildings, usually we have an alarm bell, right? The alarm bell is continuously ringing. There is no pause. But in some buildings, we have seen that the alarm bell will ring and then pause, then ring, then pause, then ring, then pause. So some they are following the temporal 3 pattern, but some they are not following. Right. So basically, why some are following and some occupancies? Why? Because there are no multiple signatures available in one occupancy. The confusion comes when you have multiple hazards and one signal. Like for example, if I have carbon monoxide, now carbon monoxide alarms installation is not compulsory by the civil defense. It is not compulsory to have, so you have each and every house should have a carbon monoxide detector. It is not compulsory. Okay, you can have, you cannot have. Okay, so for example, now if a carbon monoxide leakage is there in a building, it does not require you to have a complete evacuation. You just have to open the windows, and then you have to make sure if your condition is okay. If not, then call the authorities. The whole building does not need to evacuate, right? But on the other hand, the evacuation signal requires the whole building to evacuate, which means there's a fire threat in the whole building, right? So these two signals, they both have their own priorities. So that these two signals are not merged with one alarm bell, so they have different temporal patterns. Okay, so one has temporal 3 pattern and one is temporal 4 patterns. In oil and gas industries, you will see that multiple alarms are there, the multiple patterns are there. So they will know that, okay, this alarm is there, it means we have to gather to the assembly point. This alarm is there, we have to evacuate suddenly outside of the occupancy. Okay, we don't have to wait anywhere. So like this, they are trained for it. But in residential buildings, there's no specific training. And because of that, we usually have signals that are based on temporal 2 or 4 patterns. So we usually we have one alarm bell for evacuation only. Okay, so carbon monoxide, neither the civil defense enforces or nor the people, they have to learn or differentiate among the signals. When they see the signal, hear the signal, they just need to evacuate. That's it. Okay. So that's for the notification appliances, audible ones. Okay, we'll just end the session here. Okay, and in the next lecture, we will discuss about the visual notifications. Okay, and we will discuss about NFPA 720, that is carbon monoxide household equipment. Okay, and then we'll move on towards section 17, that is the fire extinguishers. But before moving that, we will take some sample questions from detection and alarm. Okay, we'll discuss those questions. Okay, and then we'll move on towards section 17, that is the extinguishers. Okay, any questions regarding to this lecture, anything that you want to discuss? Any questions, anyone, guys? Any questions, anything? Any questions? Okay.
Say, excuse me, security system also including in the NFPA 72.
Security systems are not the part of the blueprint. Okay, uh, but they are, yes, they are included in NFP 72. Okay, so we will just follow the blueprint and as per the syllabus. Study material will be shared. Okay, because the section was not completed. Section 2 was not completed. Today the section 2 is completed. So with the recording, you will get the slides, and as well as the MCQ question also you will get. I mean, each and every section is having like 15 to 20 questions, 20 to 25. Okay, but don't worry, at the end of all the sessions, we will have like mock examination discussion. We'll have like say 70 questions we'll discuss live. Okay, so this is just for the practice. Okay, so there will be like 20 questions that will be there. Okay. But last time the section was not notes were not shared because the section was not completed. Usually, once the section is completed, the notes are shared accordingly. And sample test will also be shared. The test that we have discussed today, it will be shared.
One more thing.
Yes.
Is the question the repeating the same one or it
No,
will
no,
be
no,
changed?
no. This is just for practice. Okay, the questions for practice. They are not repeating the questions. The questions will be different, but as that is why we are going for more, descriptive type of training. Okay, so that if they can twist a question in any way, we will be able to handle that one. Okay. Uh, Remember one thing: we have been the part of the certificate advisory group. We know that the NFPA itself also knows how many question banks are there in the market. Okay, so they are well aware of it. Okay, so of course they will always be changing the questions. Okay. Yes, Ibrahim.
Okay.
Okay, the monatomic particles. Okay, what happens is that infrared, it passes freely through diatomic symmetrical particles. Okay, diatomic symmetrical particles like O and O2. Okay, they are both of oxygen atoms, same bonding. Okay, N2, N usually both are the same diatomic. O2 and N2, they both are diatomic. Means diatomic means both are same atoms. O and N. So you will see that our dry air is majorly composed of oxygen and nitrogen. In the last lecture, we discussed that oxygen is 21% of the and nitrogen is 79% of the dry air. So they are diatomic particles. So infrared will pass freely, means it will not get absorbed. But whenever an monoatomic or monoatomic asymmetrical particles like CH4, carbon monoxide, carbon dioxide, okay, any type of hydrocarbon, CH, C3H8, any type of carbonaceous fuels, whenever they will come, okay. So what will happen? Sulfur dioxide, the infrared, it will get absorbed. Okay, why? Because it tries to it uses its force to remove the most outer electron from the shell. So it uses its force there, so it gets absorbed there. Okay, so monatomic asymmetrical particles, infrared will get absorbed, means you will not get anything at the receiver. But in dry air you will get uh, the infrared at the receiver end. Like for example, in malls, when we have like this thermal type of detectors, IR detectors, okay, so we usually stand in front of a detector at a specific distance. Why? Because the infrared radiation passes through dry air and reaches our body and then measures and gives us the temperature, what is the body temperature of our body, calibrated, right? But whenever a monatomic gas, means carbonaceous fuels, whenever it goes in that travel, the infrared will never reach towards the body. Okay, it will get in between, it will get absorbed. Okay, so this is the characteristics of the infrared absorption. Mhm. Okay, guys, associate, I will just end the session here, so the recording is downloaded. So see you next week for the continuation of the lectures. Okay, study materials will be shared with you, the group. Okay, have a nice day. Take care. Mm.